I'm gonna do a quick monkey type. Enter. Yeah. Alright. That's alright. Let's see. One Leetcode question. Let's do one Leetcode question. Can I create a new tab? Or not? Probably not. That's okay. Just open up a new tab like that. Okay, binary search. Search a 2D matrix. I'm gonna go to my downloads folder. And the matrix. And the target. Target of 10. Okay. Let's have a go. So you're given an m by n 2D integer array matrix and an integer target. M by n 2D matrix and an integer target. Each row in matrix is sorted and non-decreasing. Okay. The first integer of every row is greater than the last integer of the previous row. Makes sense. Return true if target exists within matrix or false otherwise. Can you write a solution that runs in O of log m times n time? Okay, so that's binary 2D search. That seems like binary 2D search to me. Damn. How would we go about it in a 2D manner? Let's see, if you search by left to right first, say, you know, that's log of m, or sorry, m times n doesn't matter, okay. So say the whole thing is, so 1 to 8, that is n, 1 to 14 is m, so we have n. If we just did binary search on n, that would be log n, but then you do it as a linear search down here would still be n log m, m log n. Then the problem is you need to probably do 2 logs. Log m times log n. What was it? Something about m and n, when you times them together, can you just compose them? I forgot about that. Log mn is, yeah, that's what I thought, right? Is log m plus log n. So you'd need to do a log n and then this. I can understand. Doesn't necessarily need to compose or say like a for loop in a for loop. But log m times n is just log m plus log n. So we needed some way to just do 2 binary searches. And how to go about it. Say your target is 10, right? Target is 10. One and 8. Ten and 13. Is m in 10 and 13? If not, oh sorry, is target in 10 and 13? It is. Now do binary search on that, and you want to return true if target exists and false otherwise. So you don't need an index anywhere, so maybe a while loop is unnecessary, but you can do it maybe in a recursive manner. for this matrix. Give me a second. I'm gonna just see if I can see the live. Okay. Search matrix. Probably do the 1, 10 to 14 first before doing left to right. If I go, let's see, top to bottom, I feel like I can try it, I guess. I don't think I can get this right, but we'll see. And 1, 10, 14, 1, 10, 14, yeah. No, I don't want to go down the wrong path, man. I don't want to go down the wrong path. 1, 10, 14. What, you look down the right? Just try it. Well, L is less than R. Okay, this is the right side. So I need this to be -1. while L is less than R, matrix L plus equals matrix L is the 0. Can we guarantee that M is going to be greater than or equal to 1? Okay, so we can say, god damn it. Zero. So matrix 0. Middle is equal to L plus R minus L, R minus L, div 2. Div 2. Or floor divide 2. So that's the midpoint. So R and L, if R is 3 minus 1, that's 2. Div 2, floor divided 1. L plus 1 is 1 plus 1, which is 2. So second, oh wait, L starts at 0. Okay, let me try that again. R is 2 and 0. 2 minus 0 is, yep, still 1. So it becomes 1. So the index becomes 1 there. And that's the matrix first value. And we want to make a condition where the matrix value, if that value is less than, is, alright, let's just do greater than the target. That's greater than the target. M. See, M. So if it's greater than the target, then you want to move the R pointer to M. And you want to move it to M, but we already looked at what M was, so you want to do M minus 1. M minus 1. Elif matrix M is less than target, L equals M. So if the matrix value is less than the target, then you want to shift L forward up to M plus 1. Yeah, I think that still makes sense. Else, the matrix, it'll be just equal. So, oh, you can't find it, right? So there is a chance that you can't find what you're looking for. If you do find what you're looking for, okay. Nah, okay, so I'm just doing binary search again, but there should be a different trick to it, right? A trick to get the condition right. So I think these conditions are wrong, actually. Matrix M0 and M plus 1. M0 maybe it's a 3 condition problem. Matrix M is greater than the target, greater than the highest bound of the target. Highest bound of the target. The highest bound else it's between if it's in between else the M to look for, or well, it is M, but row column, alright, the row, alright, row is equal to M. Row is equal to M, and this is the index. Row, I don't think you need to initialize this because there might be a guarantee, so I'm not going to initialize it. However, the row can now be used in a binary search to find the solution. So we reinstantiate L equals to 0. R is equal to 1. Sorry, len of matrix M and that's only the len directly to the end. We need a -1 to actually get the value of the pointer at the last point in that matrix. Okay, while L, okay, less than equal to might be what I need, because that's what I needed last time. I'll just keep it less than equal to, because I think this prevents a I guess infinite stack overflow. Stack overflow, maybe I'm using that term wrong actually. Okay, while L is less than equal to R, we're setting the midpoint. I guess I could call it N, sure. N is equal to L plus R minus L div to the midpoint if I can just do a normal binary search now. Matrix M N is greater than target. I feel like there might be some repeat code here actually. Matrix MN target. MN target. So that is greater than the target. The right should go in the opposite direction. N minus 1 minus 1. Elif matrix M N is less than target. L is N plus 1. And plus 1. Else it's exactly equal and we return true. Else we return false. Okay, M is possibly unbound. Is that really the case? Row M. M is possibly unbound. I think in our scenario, our constraints, M has to be greater than or equal to 1. So hopefully it shouldn't matter. Oh man, we'll see. I'm pretty sure I messed this up anyway. Python. Right. Let me think about this. Let me think about this for a second. Okay, I'm gonna just copy and paste this. No, that's not what I want. VLine to 2G yank. Control V. Okay. Right, okay. If I'm not mistaken, we actually have problems with this, so I'm gonna just open it in VS Code. This is actually only my second time ever using a Linux machine, as in a Linux machine, to do the streams. Okay, just want to copy that. Copy and paste. Control V. Control V. Okay, it's gonna fail. It's gonna fail. It's gonna fail. Oh, time limit exceeded. I mean, it passed the base cases. That's actually good. That's actually good. You may have an infinite loop in your code, or it is too inefficient. Let me think. 1, 2, 4, 8. 10, 11, 12, 13. Last executed test case. Oh, is that not the same one as part of the solution test case? This one is use test case, run. Yep, so this third one is the wrong answer. So 1, 2, 4, 8. Expected true. Wait, what was the output? Sorry, what was the submit? Time limit exceeded. Expected true when it got false. 1, 2, 4, 8, 10, 11, 12, 13. 14, 20, 30, 40. Target of 10. L and R. In this scenario, we got to here, and then while L is less than R, the current n became 11, right? Because r minus l is 3 minus 0. Sorry, 0, 1, 2, 3. 3 minus 0, which is 3 div 2. Floor divided means it's 1. So we got n is equal to, starting from 0 plus 1 is 1. So it goes from 11. 11, if matrix here, 11, is greater than target, which it is, the right pointer becomes the right pointer becomes 10. N minus 1. 10. Right? And then you probably still have to do this check. Rather than skip it entirely, because L and R right now are here. Man, okay, well that's, I think, one of it. Still outputs false when it's meant to get true. MN so if L and R, so L and R is 0, 0 to 0, L is just L. So that means N is going to be not greater, not equal, so it's just going to be equal. Which it should have worked then. In the case where that was just a less than. Oh shit, wait, this is less than, I should keep that equal then. Yeah, okay, well I actually know why we should keep it as equal. I was thinking about it the opposite way around. Okay. I was thinking about it a bit opposite. Alright, let's have a look at the solution. I'll probably close this one and just look at the solution here. Video Expo.
Hey everyone, welcome back, and let's write some more neat code today.
Oh, wait, I gotta put on headphones.
So today,
Okay, wait, hold on. I just realized I should wear some warmer shoes. Alright, let's go.
let's solve search a 2D matrix. And I really like this problem because it's not one of those problems that you need a fancy trick for. You can actually solve this problem just by using logic. So we are tasked with creating an efficient algorithm for searching for a single value in an m by n matrix. The matrix has two properties. In every single row, the integers are sorted from left to right, and the first integer of each row, for example, this 10, is always going to be greater than the last integer of the previous row.
Yo, is it? I feel like I overcomplicated it then. You know what I mean? Like, I didn't need to do a 2 by 2. I could have just thought of it as, concatenating them all. And it could have just been done in a formulaic way.
So greater than this one. So in other words, we know that each row is sorted, and then the next row is going to be greater than that. So technically, each value in total throughout the entire matrix is going to be in sorted order. So that's pretty good. In this example, we were given a target 3, so if we search for the target, we will find it right here. So then we can return true that it does exist. If it does not exist, then we simply return false. So how can we solve this problem? The key word here is create an efficient algorithm. What would be the brute force? Of course, we could do an algorithm O of m by n, basically by searching every single value in the input array, right? That's a pretty easy algorithm to do on a two-dimensional matrix, but can we do better? Of course we can, because they gave us a couple properties that this matrix has some sorting already applied to it. Assume that we just had a single row, like forget that we had a matrix. If we just had a single row like this one, and we know it's in sorted order, do you know an algorithm that can search for a target value in a sorted array? I know of one called binary search, right? And how efficient is binary search? Well, let's say
log of n.
The size of this array is n. We could do a binary search in log n time, right? But of course, we know that we actually have m different rows, right? So let's say we ran a binary search on every single row until we found the input target value, right? What would the time complexity be? Well, log n multiplied by m is going to give us a solution like that. So that's using the first property, knowing that each row's integers are sorted. And this is a pretty good solution, but can we do even better than this? I'll give you a hint. We're definitely going to have to use this second property that they told us. Each row itself is actually in sorted order, as in we know that the values in this row are going to be smaller than all of the values in this row, and all of the values in this row are going to be smaller than all of the values in this row. So can we use that property to, instead of searching through every one of these m rows, maybe we can actually do a binary search just to figure out which one of these rows to search in the first place? Because, for example, if we're looking for a target value 3, let's take a look at this row. This row could have any values between 10, which is the lower bound, and between 20. So obviously the target value 3 is not going to fall within that range between 10 and 20, right? So then the question is, okay, if the target value is definitely not in this row, we can cross this row out. But then which direction are we going to go? Are we going to look at the row above it, or are we going to look at the row below it? Of course we would want to look at the one above, right? Because above, the top row is going to have smaller values than the bottom row, right? So when we cross this row out, we can also say that, let's cross this row out too, because of course this row is going to have greater values. That's how the binary search is going to work, to even figure out which one of these m rows we're going to need to search, right? So we can reduce, instead of m, we can do a log m by running binary search. After we've ran that log m search, then we know, okay, this is the row that we have to do our second binary search on. So after we're done with that, we're going to do another binary search. So let's plus here log n, right? Log n for binary searching the row itself. So that's a exactly better time complexity than we had previously, right? Log m plus log n. That's pretty dang good. So once we get to this row, we're going to say, okay, 3 is what we're looking for. Does that fall in the range between 1 and between 7? Of course it does. So either our target value exists in this row, or it doesn't exist at all. So let's run binary search here. So of course we're going to have 2 pointers, left pointer and right pointer. Then we're going to check the middle value. In this case, I think the middle value is going to end up being this one, because 0 plus 3 is going to become index 1. But let's just say it became this one, just to kind of show you what it's going to look like. let's say our middle value is here. We're going to check, okay, 5, is that 3? Nope, 3 is less than 5. So what we can do in our binary search is cross out these values, cross out our pointers. Now our right pointer is going to be over here. And let's say we ran binary search again. We compute the mid to be over here. We check, is this 3? Nope, 3 is greater than this. So we cross this out and we shift our left pointer over here. Left and right are both here. Middle is going to be here as well. We're going to see, okay, either this has to be 3 or nothing, or 3 just doesn't exist. Of course, this is 3. So we found it. We can return true. And that's the entire solution. So it's just a double binary search, and we can implement that pretty easily once you kind of know how to do binary search. And if you don't, I'm going to show you how to do it right now. So now let's get into the code. So the first thing I like to do is actually get the dimensions of the matrix. So let's get the rows and the number of columns in this matrix. We can do that pretty easily because we know for sure that the matrix is always going to be non-empty. And now we're going to do the first binary search. We're going to look for the row that we need to find. So I'm going to have 2 pointers, one for the top row and one for the bottom row. Top row is 0. The bottom row is going to be the number of rows minus 1. So now we're just going to continue to do the binary search until we can either find the target row or we figure out that the target row does not even exist in the binary search. So one case is that the target value is even greater than the largest value in this row. So let's go to that row. Okay, first, before I do that, let me actually compute the row. So we want the middle row. In this case, we'll take the top and bottom and divide it by 2. That's kind of how binary search usually goes, right? So, and then we have that row. So in our matrix, we're going to look at that row and we're going to look at the rightmost value. In Python, you can do that with -1, but we could also just do number of rows minus, or the number of columns minus 1, but in Python it's a little bit easier. So we're going to check, is this target value greater than the largest value in this row? If that's the case, what are we going to do? Well, then we need to look at rows with even larger values. So what we're going to say is our bottom row is going to end up being the 1, because now we want to look at rows that are larger than this row. Else, if the exact opposite happens, so let me copy and paste this, if the target value was even less than the leftmost value in the array, aka the target value was smaller than the smallest value in this row, in that case, we need to look at rows with smaller values. So we're going to shift our top pointer. Actually, I think I just did it backwards. So when we look for larger values, we actually want to take our top pointer and then shift it down, because when you go down in the matrix is when you actually get larger values. And if we want to look for smaller values, we're going to take our bottom pointer and then shift it up. In that case, we would want to set it to be row -1. So that's the case if the target value was either too big or too small. If neither of those evaluates to true, that means that the target value is actually does fall within this current row. In that case, we just want to break out of this while loop.
So I had a similar idea, but I see that we are slightly different. Although it might not be a problem. So he did bot and top, I did L and R. R is my bot. Bot row -1 when matrix of -1 is greater than target. So I did the highest value on the right and the lowest value on the left. But here's the thing, okay, so matrix M -1 is you're getting that is greater than the target. If it's greater than the target, then your R is going to M -1. If the matrix you're basically saying it has to be, if it's 0, then the leftmost. So that's the leftmost. And that's on the rightmost. I guess it would be false all the time. Oh, that's why I'd be getting falses then, probably.
And then we can do the second portion of the binary search. Now, it's possible that if we did not break out, maybe we just created an invalid condition where we figured out that the top and bottom pointers are invalid, right? Then our while loop would stop. And what that would tell us is that we crossed out every single row in the matrix and none of the rows contained the target value. In that case, we have to return false immediately. So basically, if not top is less than or equal to bottom, that means that none of the rows contain the target value, and then we can just immediately return false. If that's not the case, then we're going to move on to the second binary search portion, and we're going to run binary search on the current row that we found from the top and bottom pointers. So let me just copy and paste that. This is the row that we're going to run binary search on. And we're going to have a couple pointers, left and right, which is going to be 0, and columns -1, because that's going to be the rightmost position in the row. And we're going to do pretty much the exact same thing that we just wrote above, a second binary search while left is less than or equal to right. Let's compute the middle point. We can do that by taking left plus right divided by 2, and now we'll do the same thing. So if we find that the target value is greater than the value in this target row
let me see if that was literally the only change that I had to do, because if so, goddamn, you know what I mean? -1. Okay, infinite loop. You break it. Fine. I'll break it. Do I ever use row here? I instantiate a row, but I never use it. I just use the M. Damn, bro. I'm too good. Okay.
position middle, that means we have to search towards the right of the row. We have to search towards the right of this middle point, in which case we'll say our left pointer is going to be M plus 1. We're going to search towards the right. Else, if the exact opposite was true, then we want to search towards the right so we can shift our right pointer to be mid -1. And else, the last case is if we actually did find the target value. In that case, of course, we can return true. Now, if this loop exited but we never returned true, then outside of the loop, then we have to return false, meaning that we never found the target value. Okay, I just forgot that when we were copy and pasting, I forgot to change this condition. So the first one, of course, is if target is greater. The second else if is if target is smaller, then we want to shift the opposite pointer. And that is the entire code. So you can see that it's pretty efficient. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
Okay. I will write a little bit of information here just about this problem. Solved 99%, or let's say 95%, but fixed bug only when looking at solution through Neetcode. there is also a second possible approach that could simplify the approach taken by Neetcode, but it would require formulae. As opposed to two binary searches. Another thing that I've remembered is O of log n times m is equivalent to O of log n plus O of log n log m. Okay, log n times m. Yeah. Okay, that's good. That's good. That's good information that I've gathered, and I will call it that for that question. Because today I want to do some more scheduler development, because I've been obsessed with that over the past few days. Coco eating banana is the next one. With the solution to this, I want to also complete it in Leetcode. Okay, and the solution here oh no. Wait, did I even get this right? Zero. Close bracket. X. Insert. -1. And you break. If I go back to VS Code's not open. Okay. Copy and paste. Control V. Control V. Submit. Yippee. 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 Okay. We can close some of these now. Monkey type again, you know, just before we transition on. Onward and outward. Oh. Oh. No, I'm not gonna bother. I'm not gonna bother. cd scheduler and vim. Okay. Okay. Close that. I'll keep that open. And let us. Is this still connected? No. Okay. What? What just happened? Quit all. Hold on, actually. Yeah, quit all. Poetry. Dash. C. Backend. Shell. And vim. Epic. Quit all. I can close this actually. X. Dash ff. Let's open. What should we do? Is this? Yeah, no, okay. Let's just see. We might want. Let's look at the sidebar. SRC, client, or stories. Might want stories. Roots. The layout. Although the biggest thing is the components. We want to get the navbar component. Cool. The navbar component. I will open up another terminal. Let's see, how will I want to open up another terminal here? Maybe I'll just open it up to the side. New window. Just a new window. Off the screen. Man, it's so cold at my house, we don't have heating. So, yep, we're just chilling. Neovim is not what I want. I need to go to the front end directory. Maybe I'll show you what I'm doing right now. Yeah, okay. Front end directory I'm in, and npm run storybook is what I want. And then that'll actually, control C this, control C this, control C, control FG. Let's go, control C. Okay, that's not what I want. Because we want to nvm use the correct version of Node. before we do npm run dev. Sorry, I mean storybook. Okay, and that's what opened up. Goes this one. Move this to the side. Okay, so we got our spinners, we got our nav bar. Okay. Dashboard. Nav bar. No battery on my headphones anymore. Just gotta put that away now. Okay. Dashboard, docs. Calendar goes directly to the calendar. Mobile menu button. 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 Is there a hover? Shrink there. Yeah, okay, you can still see the CSS equivalent on the sides of this, which is nice. Open main menu. Block H6, aria hidden. Okay. CSS. CSS. Open main menu. Flex. 1 item center, justify center. Small justify center, flex string, items center. Ooh, actually. Before I even look further, there was something I wanted to do, which was, there was some comments recently that I haven't responded to yet. Where's the comments section? Here we go. What? I'm so confused. One comment was like, you speak TypeScript to your wife? Sure. Okay, are you building it with React? Yep. Yep. React among others, though, such as 10 stack router, query, and now I just say yep. Okay. I missed the entire joke, maybe. I'm not gonna bother. Okay. It's a bit elevated. Alright, right where we left off. Let's go. Let's see, what should I even do? Well, you see, like, I look at all of this. Maybe, yeah, okay, let's have a full study of what this code block is. And then we'll also, after this, have a look at the Odin project and continue off the React route to see what else we can learn. Mobile menu. The mobile menu. Oh. Right, I wanted to make it simpler for myself. So one of the tasks that I wanted to do more recently was use viewports in storybooks for the nav bar. So try component testing. Okay, use viewports in storybooks. Okay, viewports, storybooks. Storybook. Alright, the viewport toolbar allows you to adjust dimensions of the iframe your story is rendered in. It makes it easy to develop responsive UIs. Configuration out of the box, the viewport add-on offers you a standard set of viewports that you can use. If you want to change the default viewports, you can set the global parameters to your storybook preview.js. So, apply outlines. Right, viewports, right? Change the size of preview, small mobile, large mobile, tablet, reset viewport. Was there a way to have specified viewports? Oh, no. The viewport global can take an optional set of viewports, use a detailed set of devices. Add a new device. Configuring per component or story. Okay. I'm gonna watch it off my device on the side here, just because my headphones are charging right now and I don't have volume at all. Viewport storybook.
How do you test?
Okay, set a default viewport. Okay, I think that's what I need to set a default. Oh, I'm sorry. I keep on sniffing, by the way. I'm sorry about that. Let's set a default viewport. Hmm. 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 Maybe I'll just call this desktop. So viewport. Viewport. Default viewport. The default viewport being small mobile, large mobile, or tablet. Should be way. Let me have a look to search. Default viewport. So some default. If you want to change the default set of viewports, you can set the global parameter viewport parameter to your default viewport. Disable the viewports, the configuration option. Mobile. Is that all I need to write? I don't think so. We'll see. Wait, do I have... No, I don't. Then, right. Desktop, mobile. Desktop. No! So I don't think that's the right default viewport. Use a detailed set of devices. Small. So, look, we had a few. Small mobile. I'm gonna guess this is all I need. That's my guess. I don't think it's it. That's not it. Oh, it's called Mobile 1. I'm looking at the docs. Ah, yikes. I can't show it on the canvas. Ah, so I have to make it, I think, a canvas, specifically for this. Let me assume that I will go to create a new file, navbar.mdx, and then in this file, let's see, we should also open up like a spinner.mdx maybe, just to use as a boilerplate. G yank. Yo. Undo. V G yank dash ff sorry. Now we need navbar.mdx. Paste. DD. Spinner stories. We're gonna change every instance of spinner. Oh man, how do I do that again? I wrote this down. %s %s spinner to stories navbar stories. Insert. So 2G FS. Oh man, oh damn, I figured this out. Okay. CIW nav. Oof. I'm getting beat. Nav bar stories right quit right. Okay, I think that's because it's autodocs. Ah, man. Control C. Just do it again. Navbar. No. Undo. Undo. No, that can easily get out. Oh. I suppose I haven't even DW. Dang. I mean, I can use the default viewports. It's just a little bit a nuisance for now. There is only calendar. That's fine. Okay. Navbar.tsx. What's been changed here? Okay. What do I want to do? Man. Alright, let me close that. Maybe snap this across. Open. Home. David. Development. Schedule. Make some changes. Alright, the Odin Project. Sign in. Hiding. Not hiding anymore. Intermediate. React. Keys in React, passing data between components. Introduction to state, more on state. Class-based components. Component lifecycle methods. Introduction to React testing. Mocking callbacks and components. The React ecosystem. Okay, keys in React. In this lesson we cover keys in React, our special props for our components, and we'll learn why they are used. This section contains a general overview of topics that we will learn in this section. What are keys and why does React need them? What are good and bad examples of keys? Why does React need keys? In the incoming lessons, you will learn more about the internal workings of React, more specifically re-rendering process. For now, we'll keep it short. In the previous lesson on rendering lists, we used the map method to iterate over an array of data and return a list of elements. Now imagine if any of the items in the list were to change, how would React know which item to update? If the list were to change, one of the two things would happen. We would re-render the entire list, or we hunt down the specific items that were changed and re-render those. Assuming we want to hunt down one specific item that wasn't changed and not re-rendered the entire list. When the list is updated for whatever reason, either from a server or interaction, server React matches the keys for each of the previous list to the updated list. If there were any changes, React will only update the items that have changed. As long as keys remain consistent and unique, React can handle the DOM effectively and efficiently. We'll be using props. We'll be using props here, and you will learn more about them in the next lesson. For now, you will need to know that props are arguments that are passed into components. Keys are passed in the component or a DOM element as a prop. You should already be familiar with the syntax. Now that we know the syntax, the next question is, why should we use as key? What should we use as key? Ideally, that should be some identifier that's unique to each item. Most databases unique ID, so you shouldn't have to worry about assigning it yourself. If you're defining data yourself, it's good practice to assign a unique ID to each item. You may use the UID package to generate what a UID looks like. To-do list, your UID, and then to-do ID. Here's already generated as ID a key. Additionally, if you're sure that the list will remain unchanged throughout the application's life, you can use the array index as a key. However, it's not recommended since it can lead to confusing bugs if list changes when items are deleted, inserted, or rearranged. You will learn more about this in the assignment section linked to the article. Keys are straightforward to use. Keys are straightforward to use. Though there is an anti-pattern you should be aware of. Keys should never be generated on the fly. While rendering the list defeats the purpose of the ID, as now a new key will be created for every render of the list. Shown above the example, key should be inferred from the data itself. I mean, should be fine, yeah, that makes sense. Okay, so don't fret if some of the terms covered in this lesson don't make sense. What's crucial right now is knowing how to use keys effectively. As mentioned earlier, the more you learn about React, the more you will understand the importance of keys. Furthermore, using keys is not limited to rendering lists. You might encounter use cases where keys are needed. We'll leave that for you to discover. Read the section on keys in the React docs. Okay. I did read this already. You need to give an array of items. Keys tell React which items components can match them up later. This becomes important if your array can move due to sorting. Get, insert, and get delete a well-chosen key helps React infer what exactly has happened and make the correct updates to the DOM tree. Rather than generating keys on the fly, you should include them in your data. Displaying a several DOM node for each item, where to get your key. Different sources of data provide different sources of keys. Ooh. Hello, Cigaras. It's nice to see you again. Nice to have you on the stream again. I'm going through the Odin project again. If you didn't notice, or maybe you already did, because now I want to get more familiar with. I want to get to the part where we talk about states. See. So I've done this much already for the React section, but I want to get up to states. So states and effects. I want to do, yeah, I mean probably just before the project or just like skip the projects. Yeah, we'll see. Yeah. Why does React need keys? Recap. So that's fine. I'm fine with all that. Tab to the left. Go back. Knowledge check. The following questions. Okay, read the section on keys. Watch this short video demonstrating index as key binding as an anti-pattern. Okay. Actually, that's not it. Index as key anti-pattern. Okay. I'm gonna have to watch this. Only problem is my headphones are still charging. I'll unplug it for this video. Do it for this video. Docs menu in the menu bar. Chat. It's kind of working. Okay.
When reading articles or going through React tutorials, you're often going to see a lot of examples where developers use the index of an element as the key for list rendering. It keeps the code simple and elegant, and of course gets rid of the warning you see in the console. In this video, I want to show you how to use the index as a key when rendering lists, and also the problems you might face when used in the wrong scenario. I'm going to go back to VS Code, and in the name list component, I am going to add back the names array. Const names is equal to an array of strings, Bruce, Clark, and Diana. Let's render this list of names instead of the person's array. Const name list is equal to names.map, and the map method takes in an arrow function. Let's call the parameter as name, which represents the array item in each iteration. Within the function body, let's return an h2 tag with the name as inner text. And the name list component now returns name list instead of person list. If we save the file and take a look at the browser, you can see that we are rendering the list of names. If we open the console, we of course have the error. But we do know how to fix this error. We need to add the key prop. There is one problem though, which we did not have before. We don't have an ID that uniquely identifies each item in the array. We could use the name itself as the key. So in the map method, on the h2 element, the key prop, and this is going to be equal to name. If I save the file now and take a look at the browser, you can see that the error is gone. But what if there is duplication of names? Let's add Bruce again to the end of the list. Now the name is not unique anymore. And if you remember from the warning, the key prop has to be unique.
Yeah, okay,
if you take a look at the browser, you should be able to see a new warning. Encountered 2 children with the same key, Bruce. Well, it turns out the arrow function that is passed to the map method receives a second parameter, which is the index of the element in the current iteration. Let me show that to you. The arrow function will now accept 2 parameters. So we need parentheses, name and index.
Okay.
We can now use this index as the key when rendering the list. So key is equal to index. Let me also display the index so as to get a better picture of how it works. If you now save the file and take a look at the browser, you can see the list displayed along with the index.
0, 1, 2, 3.
You can see that the index starts at 0 and keeps incrementing for every element in the array. And that way, every item receives a unique key value. So this is how you can use the index value as a key for list rendering. The index is passed as a second parameter to the arrow function within the map method, and that index is used as a value to the key prop. Let me tell you though, using the index as a key will cause some serious UI issues in certain scenarios. And to demonstrate such scenarios, I have modified a CodePen example from the React docs. The link will be in the description. At the very top, we have 4 buttons. Add a new item to the start of the list, add a new item to the end of the list, sort the list by earliest created date, and finally sort by latest created date. Below that, we have a table with the headings, index, which specifies the position of the item in the list, an ID, which is self-incrementing, item, which is an input where we can enter a value, and the created at timestamp. On the list, we are using the map operator. The arrow function accepts 2 parameters, to-do, which represents the item in iteration, and the index of the item in the list. The same index is used as a value to the key attribute for rendering the list. Now back in the UI, for the first item, I am going to add a value of 1. Next, I am going to add a new item to the end of the list. You can see that a new row is inserted into the list. The index is now 1, ID is incremented to 2, the timestamp is also present. Let me add a value of 2. Similarly, if I add another item to the end of the list, we see the same behavior. Everything works as expected. Now what should happen if I add a new item to the start of the list? For the new item, I would expect the index to be 0 because it is at the beginning. The ID, however, should be incremented, so it should be 4. The value should be empty and there should be a new timestamp. Pay real close attention. When I click on Add New to Start, you can see that a new row is inserted. But it doesn't quite work as we expected it to. We expected index to be 0, so that works. We expected ID to be incremented to 4, so that works as well. The timestamp is new, so that also works. But we expected the value to be blank or empty. Instead, it has a value of 1. And the last item in the list, which previously had a value of 3, is now empty. This is the problem of using the key as index. Let me show you how React interprets the update. Initially, we have the 3 items with the index as keys. For key 0, there is a value of 1. For key 1, there is a value of 2. And similarly, for key 2, there is a value of 3. Now when you insert a new item at the beginning, the new item gets an index of 0, which effectively creates a key with a value of 0. And that pushes the key value by 1 for the remaining elements. When updating the UI, React thinks that, hey, I already have the 3 elements with key equal to 0, 1 and 2. Let me reuse them and then insert that new item with key value of 4. Oh, and as it turns out, the first 3 items had some values. Let me put them back. This is how, even though we inserted a new item at the top, it appears as though it was inserted at the bottom and the values are all messed up. And this is also the problem when trying to sort the list. If I go back to CodePen and refresh, we should have a single item. I will add 2 more items to the end of the list.
Okay.
So 3 items with value of 1, 2 and 3. Each of them with different timestamps. If I click on sort by earliest, the timestamp should be in ascending order and you can see that the list is sorted. When I click on sort by latest, the timestamp is in descending order. But item values don't seem to be in the right order. Irrespective of me sorting by earliest or latest, the item values never change. This again is because of using the index as key when rendering the list. Now you might have a question. If using the index as key results in such issues, why do so many articles or videos do that? Well, it turns out you can use the index as a key provided your list satisfies certain conditions. The first condition is that the items in your list do not have a unique ID. If the items do have a unique ID, always go with that. The second condition is that the list is a static list and will not change. For example, you are never adding items to the list or removing items from the list. Finally, the list will never be reordered or filtered. For example, sorting based on a column value or filtering based on user inputs. When your list satisfies not just one, but all the three conditions, you can safely use the index as a key. Most of the times, you end up having a unique ID, or the list will be satisfying the three conditions. If not, you can try one of the NPM packages that generate a unique ID for a list, or also try hashing out a unique value from one of the existing properties. But the bottom line is, try avoiding the use of index as a key and let that be your last resort. In fact, React uses the index as the key if at all you don't specify the key prop. And of course, we have just learned how that can be a disaster in certain scenarios. Alright, I hope you now have a good understanding of lists and keys in React. Thank you guys for watching. Don't forget to subscribe. I'll see you guys in the next video.
Okay, so you could still be confused. What do they say here? So you have array ABCD of letters which map to 0, 1, 2, 3 indices. React shows up as key 0A, key 1B, key 2C, and you take out the second letter B through the array and ABD, which maps to 0, 1, 2. React shows key 0A, key 1C, key 2D. What we want to see is key 0A, key 2C, key 3D. Basically, you know, indices and keys and lists. Okay. The following questions are opportunities. Why does React need keys? Have a unique identifier for each item. How do you use keys? You pass in a key prop to each item in the list. Unsorted list. And you map the key prop. Where should the key value ideally come from? An internal ID from a database. When can we use an array index as the key value? Only when it is not sorted, when it's not sorted, when it's not being added or deleted. So immutable, unsortable, immutable, and the only IDs that you have are the indexes. Unsortable, immutable, cool. What is the anti-pattern? What is an anti-pattern when using keys? Yeah, what is an anti-pattern? Keys are straightforward. That is an anti-pattern you should be aware of. Should never be generated on the fly. So an anti-pattern is to not use random values or generated keys on the fly. Yep. So this might also be useful. The mystery of React key. Alright, let's try and look at this video.
What I love about React, and sometimes hate to be honest, is that there is always a place for mystery there. Take the key attribute, for example. We all use it every single time we code any list in React. But how many of us actually know what it's all about? What exactly should be put there? How does it work? What is the purpose of it? Try stopping this video and ask your colleagues those questions right now. What will be the response?
Good question. What would be the response?
Most likely, the first thing that you'll hear is that React needs it to identify components and that the key should be unique. If you don't stop here and press a little bit further, you might hear that arrays index as a key is a bad practice, or that it's needed to prevent re-renders. Most of this is either not true or just incomplete. So let's take a look today at why do we actually need the key, what will happen if we use a random value as a key, what actually makes a good key, how to make lists as performant as they can be and prevent re-renders of their items, what will happen if we use arrays index as a key, and how to use key to reset state and whether we should actually use it or not. Let's start with the purpose. It's all about arrays of data here. Imagine yourself in a room with a bunch of identical kittens wearing different hats. And while you quickly left the room to get some coffee, I added another kitten to the bunch. When you return to the room, I ask you to describe to me what has changed. What will be the response? Since you don't know the kittens' names yet, the only thing that you can do is just go by the order and describe them to me. First kitten is not wearing the hat anymore. Second and third kittens now wearing different hats. And there is a fourth kitten that wasn't here before. But it's not exactly true, isn't it? In reality, I just added a new kitten at the very beginning and nothing more. The rest of the kittens stay exactly the same as they were. If only I named them before making those changes, isn't it? And this is exactly what React has to deal with when we loop over an array and try to render identical components. If we don't name them explicitly, the only way for React to identify between re-renders which one has changed and which one is new is by their position in the array. And since it's not the most optimal way to do so, it gives us the key attribute, so that we can name our kittens explicitly. And it's very important for React to understand which component is which, so that it can decide which component needs to be removed and unmounted and removed from the screen, which component is new and needs to be created from scratch and mounted, and which component has already been there and just needs to be updated with the new data. So what will happen when a component with list re-renders? React will go through the list of elements. We'll see that the key on those hasn't changed, and it will just re-render them as usual, same as any component with children. If another item in this array appears, for example, if I click a button that adds another kitten, then React will see that this key wasn't here during the previous render, and it will create and mount this new component associated with this key. The rest of the keys haven't changed, so it will just re-render them as usual. Similarly, if instead I delete an item from the array, React will see that this key is not there anymore, and it will remove and unmount the component. The rest of the components, again, they stay the same and they will just re-render. And now to the fun part. What if, instead of adding or removing items in the array, I just change a key on already existing component without actually changing anything else? Well, React will see that previous key doesn't exist anymore, so it will delete and unmount a component that is associated with it, and that the new key appears that didn't exist in the previous render. So it will create a component from scratch and mount it back. We haven't changed the data, only the key attribute. But React recognized it as a new component, unmounted it, and mounted it back, recreating it completely from scratch. So this actually should answer the question we had at the very beginning. What will happen if we just use some random values as keys? In this case, React will see that keys on all components change between re-renders. It will unmount the entire list, remove it from the
Hold
screen,
on, I go
and
back.
then, so this actually should answer the question we had at the attribute. But back. This actually should answer it completely from scratch.
Yep.
So this actually should answer the question we had at the very beginning. What will happen if we just use some random values as keys?
Ooh, right.
In this case, React will see that keys on
That's
all
true.
components change between re-renders. It will unmount the entire list, remove it from the screen, and then recreate and remount it from scratch. Consequences of this can be pretty bad. Mounting is usually much slower than a simple re-render of existing components. Also, if those lists had some state, all the data from the state will just disappear into the void. And if any of those components had focus, it will also disappear. In short, don't ever do it, ever.
Damn.
What should we do instead? Well, there is only one rule here, other than the key should be unique. The key should also be stable between re-renders. So if your data has any unique identifiable information, like an ID, key, index, or anything similar,
Yep.
use that. If it doesn't and you have no control over it, for example, if it's coming from some external REST endpoint, then you would have to generate those keys right after you get this data. Just make sure that generating process is again stable between re-renders and always produces the same result, even if this component also re-renders. But let's assume that you got the keys right, they are unique and stable. Now what? If you look at your components in the list, you will see that even if you set the key properly, they still re-render every time the parent re-renders. And indeed, the key doesn't actually help with re-renders by itself in any way. If we actually need to prevent re-renders in the list, then we need to use other techniques in combination with the key. For example, and it's usually the easiest,
Sorry, I
they
gotta
still if
go
this
back a
component
little.
also re-renders. But let's assume that you got the keys right, they are unique and stable. Now what? If you look at your components in the list, you will see that even if you set the key properly, they still re-render every time the parent re-renders.
Every time the parent re-renders. Re-renders. Key is stable, still re-renders. Component re-renders. Okay, I'm missing some assumed information here, but component re-renders. Take that as gospel for now.
And indeed, the key doesn't actually help with re-renders by itself in any way.
Okay.
If we actually need to prevent re-renders in the list, then we need to use other techniques in combination with the key. For example, and it's usually the easiest way, we could just wrap our list components in React.memo. That way, when React tries to re-render those items, it will stop and check whether their props changed or not. If the props stay the same, items won't be re-rendered. Just make sure that you memoize all non-primitive props of the list properly. Check out the linked video on some of the caveats of doing that. One tiny mistake there and your memoization.
Okay. Memoization.
Doesn't work. The most important thing here to remember is that key trumps everything else. If again we'll try to use a random value as a key, what will happen? React first looks at whether the key has changed or not, before even looking at any memoization. So if the key is random, it will change with every re-render. And then regardless of whether a component is memoized or not, it will remount. Memoization here will not work.
Yep.
In the previous examples, we assumed that some unique value like an ID is available to us for use for keys. But what if we don't have them in my data and we don't actually want to generate them? Can't I just use the array index as a key? It's guaranteed to be unique and stable between re-renders, and that's exactly what we need. What so terrible will happen? Why people say it's a bad practice? And the answer is you totally can. It's not a bad practice at all. It just has certain limitations that you need to take into account before doing so. Let's take a look at that example a little bit closer. If a normal re-render happens, it will behave as expected. Items are memoized, the props hasn't changed, so they won't re-render. Everything is okay. But what will happen if I add another item to the very top of this array? All existing values will shift their position and will get the new keys. And the new added value will have the key 0 now. From React perspective, only the item with the key number 3 is new. So React will mount the last component on the list. As for the rest of them, the key already exists. So React will think that it needs to just re-render existing components. And from its perspective, all props of those components will change. The item with the key 0, for example, used to have the value mittens. Now it has a value badger.
Yep.
So
That's
it
cool.
will just re-render
That's
every
good.
single existing component with the new data.
person
And
explains it pretty
result,
well.
even though all components are memoized, they all re-render as if memoization doesn't exist. It gets even more interesting if some of those components hold some state. For example, if by clicking on a component you can highlight it and store whether this component is highlighted or not in component's local state. Now, when you add another item at the top, from React perspective, the item with the key 0 was the one that holds the state. And after a render happens, it will continue to be so. So our freshly added item will be the one that is actually selected, not the one that we selected before. And exactly the same story will be if we just rearrange items or remove one or two of them from the middle. If you want to see for yourself how it works, links to the code examples are in the description. If instead of array indexes, we used some ID that was tied to actual data, not the data's position in the array, the result would be much more intuitive and would make much more sense. Let's take a look. Exactly the same data, only this time we use IDs as keys. If we add another item at the very beginning, React will see that only the item with the new ID is actually new. The rest of them are still exactly the same, and more importantly, their props haven't changed at all. So only the first item will be mounted, the rest of them will sit quietly and won't ever re-render. And if one of them has a local state, the state will stay at the component where it's supposed to be. And exactly the same story with rearranging the order or
That's
removing
nice.
items from the array.
I
None
like
of them
React
will
deep
actually
deep
unnecessarily
dives,
render.
Actually.
From that behavior, we can actually extract rules when it's safe to use index as key. If your array is static, i.e. you don't add, remove, or rearrange items inside of it,
Immutable.
or if it's dynamic but you don't memorize items and you don't have local state in them, then it's okay to use array index as key.
No local state.
One final thing worth mentioning
Yeah,
about the
makes
key
sense.
is that we can use it on any component, not only in lists. This pattern is usually called state reset, and it's usually used when you need to force a component to reset itself and all of its local state to the default value. It's usually used on uncontrolled components, those that have state and don't provide a way for you to control it. Imagine, for example, that in addition to this list of kittens, I have some complicated form where I can add details about the selected kitten, its breed, its color, which hat it's wearing, and so on. When I navigate between those kittens, I want to reset that form to its default empty state. One way to do it, other than turning this entire page into a big controlled component, would be just to add the key attribute to the form. Now, every time the selected value changes, the key will change as a result, the big form will reset itself, and all of its state will return to its default. But be careful with this pattern. Although we call it state reset, in reality what it does is it's unmounting the previous component, removes it from the screen, and then remounts it back. It can be slow, so performance can suffer.
Okay.
And also everything that is supposed to be triggered on mounting, like initial data fetching, will be triggered every single time. So use it wisely. That is all for today.
That
Hope
is
you
very nice. That is a very good video. Cool. Okay, passing data between components. Oh, let me X. Okay, passing data between components. By now you should be starting to understand just how powerful React and reusable components can be, but you may be left wondering, how can I share information between components? Or am I able to customize the behavior of components each time I use them? In this lesson we'll learn about React props, short properties, and show how properties to pass data between components. This section contains a general overview of topics, and you will learn this lesson passing data between components, using data to create customizable, reusable components. Okay. Data transfer in React. In React, data is transferred from parent components to child components via props. The data transfer is unidirectional, meaning it only flows from one direction, and many changes made to this data only affect child components using the data and not parents or sibling components. This restriction on the flow of data gives more explicit control over it, resulting in fewer errors in our application. No problem. Using props in React, now that we know how data transfers between components, let's explore why this might be a useful feature in React. Consider the following button component, which gets rendered multiple times within our app component. So far so good, right? We have a beautiful reusable button that we can use as many times as we like. There's just one small problem. What if we want text on the second button to be something else? Right, so we can have a different second button with a different task. Or we have to create a new button. That's kind of what we have to do. This may not seem like a huge deal, but if there are 10 buttons, each one has a different text font colors and other variations you can think of. Creating a new component for each would lead to a lot of code duplication. Let's see how, by using props, we can account for a number of variations with a single button component. There are a few things going on here. The button functional component now receives. Okay, so let's have a look first here. So color, props color, font size, props font size. Nice. So you can just put a props thing and then get it from an attribute. Okay, and props.text. Yep, and then button style. And then there would be something of an equivalent in Tailwind CSS instead of the style tag, and I'm guessing the style is pretty much like CSS. That's what I'm understanding here, I think. Yep, and then don't click me, font size, and yeah, that's reusable components. There are a few things going on here. The button component now receives props as a functional argument. The individual properties are then referenced within the component via props property name. When rendering the button components with app, the prop values are defined on each component. Inner styles are dynamic and generated and applied to the button. Prop destructuring. A very common pattern you will come across in React is prop destructuring, unpacking your props into component arguments allows for more concise and readable code. Check out prop destructuring action in this example below. Is that not the same one? Oh no, I see. I'm talking about this. Destructuring. Destructuring. I guess that is more concise. I agree, that is more concise. Not just because there is a little of a trick that they did here where they just got rid of two extra lines. Default props. Button.default props. You may have noticed the above examples there are some repetition. In order to stop repeating ourselves, redefining these column values and protect our application from undefined, we define default props that will be used for the component in the absence of supplied values. Default props, button, this and this, but how does it ever get used? I guess it's just always default props. As you can see, you only need to supply props values to button when running the app if they differ from default values defined on default props. You can also combine default props and prop destructuring. Here's how it looks like. Interesting. Okay, so default props is very good. How does that get done with some of the UI buttons here? So we've got button.tsx, button variants, button props, you know, like this is done a little differently. Default variants? Maybe. Default props. You know, I think default variants is probably part of CVA. Because these are talking about variants as opposed to properties, I think. And maybe there's a difference there. Alright. Functions as props. Let me think. Okay, functions as props. In addition to passing variables through the child components as props, you can also pass through functions. Consider the following example, where we pass handle click for on click, and you can pass that functions as props. Handle button click, and you pass in handle button click. Sure. The function handle button click is defined in the parent component. A reference to this function is passed through as a value to the handle click prop of the button component. The function is received in button and is called a click event. There are a few things to note here. When we pass through the reference to handle button click, we do not include parentheses when passing the function to button. True, if we were to do something like that, then the function would be called as the button renders. Oh, yeah, I've got a standing desk. Yep, you were thinking about why there were noises. Yep, and that's why. So yeah, I got a standing desk. I'm standing up right now. And then if you hear something else in the background right now, that's a printer. So okay, we only pass through the reference to handle button click. We do not include parentheses. Yep, it's just like passing a pointer as opposed to the function. Yeah, I don't know the other word for it. Okay, every button. Very cool. Something I plan to get in the future. How do you like it? Well, I have to use it more often than I am currently using it, because this is the first time I've stood in the last 2.5 hours. But yeah, it's pretty much like, I think it's a really good purchase. It was probably like $1,000 when I bought it. This was maybe 1.5 or 2 years ago now. But yeah, it's pretty sturdy, and I've got like, a microphone arm here. I've got a monitor arm, a different monitor which is like pretty heavy as well. So I've got like 2 monitors that are pretty heavy. This microphone arm, these keys, this mouse, and also the a laptop on the side here. So there's a lot of stuff on this table, and it's like pretty sturdy, and it's fine. The only thing that I do notice though, when you do buy this, is it's sometimes it could wobble sometimes. So there's a little bit of wobble, and that's why I don't lean too much on it with my full body. And sometimes, like, another thing is, if you want to put your chair underneath the table so you kind of have more room to walk around in the back, don't forget to take that chair out from underneath the table, just because it can maybe lead to catastrophic events whereby the table topples and it falls forward, and then it hits the wall that it's laying onto, and then it might create a dent. Not that it happened to me, but it could. Anyway. Okay, when supplying an argument to the function, we can't write. Okay, every button calling the function will navigate. What am I up to? Okay, every button calling the function will navigate to the same page. We can refactor the function and supply an argument with button to customize this functionality. Handle button URL, handle button click URL. So it takes, a URL. And then you can directly do it in there. When supplying an argument to the function, we can use onClick, handle click. We can't just write. that, and instead we must attach a reference to an anonymous function, which then calls the function with the argument, like the previous example. All good, all good. Haha, seems very specific. Thanks for that. Gives me a bit of insight into it. Would love to contribute more to what you're learning, but know very little about React. Not something we really touch on in college. Okay, I do want to say that is very true. We don't, neither in our university did we really learn about React. So that's why I'm learning it now, right? I already graduated from my bachelor's, so I'm already done with that, and I'm only learning React now. So I mean, it's as good a time as any to start learning, just to get some insight, I guess, as well in that front. And I'm going through this right now, even if you don't understand it. You can head off and do that if you want to, but the other thing is, like, if you even want to get started, I guess the biggest motivator is to start a project or, do a project. And, if you want to, you can contribute to this one that I'm doing and I'm building, which is open source, right? So anyone can just come in and help out. So yeah, although I'd probably have to give you an idea of what my vision is at the moment. But yeah, that's an option. Okay. Okay, when supplying an argument to the function, we can't simply write that. Instead, we must attach a reference to an anonymous function, which then calls the function with the arguments. Like the previous example, this is to prevent the function being called during the render. Yeah, okay, yeah. There are also other ways to implement this behavior. Curried functions. Interesting. I've read about currying in my Haskell course that I did at uni, but I've forgotten now. Hopefully you can now understand from the examples in this lesson just how incredibly useful props are for writing reusable and customizable React components. However, we are still only scratching the surface of what React can offer us. Continue on the next lesson. Read through the React docs to pass props to a component. Make sure you edit the code. I'm not going to edit the code. Pass the props to a component. Let me just go back to the previous page. Whoops. Go back to the previous page. Let me go back to the previous page. Okay. No, that's not gonna work. Okay. Knowledge check. The following questions are an opportunity to reflect on your key topics. If you can't answer a question, click on it to view the material. Additional resources. This section contains helpful... Looks like there isn't. Okay. How does data flow between React components? It is unidirectional from child to parent. No, it's from parent to child. See, I'm not the only one who experienced that, lol. Yeah. Additional resources. This section contains helpful links to related contents. It isn't required. What am I reading? Okay, why do we use props in React? So that we can pass specific information, so that we can not rewrite code and repeat code, right? So how do we define default properties on React components? You use the default properties method. The default properties, is it a method or is it a function? What are some benefits of doing so? Let's see. It's properties, yeah, so it's not a method. Sorry, it's not a method. And neither is it a function, it's just attributes or properties. And the default props, yeah. Okay, what do we have? So, okay. Do agree doing a project would teach me a lot. Guess I'm just somewhat intimidated by the fact I barely know anything. Might be a limiting factor, you know, always wanting to be prepared. Yeah, honestly. Yeah, that's the thing. There is always a friction to starting. I get that too. And then there's, I think what kind of pushed me over the edge to doing this might have been my experience with a startup that I had in the past, which I'm still currently at, but I haven't done all that much because it's not really getting paid for it, so not doing all that much for it. But during that time, you know, I learned about front-end and back-end development, or like touched on it. I touched on it to the point where, you know, I was like stumbling through understanding the content. Felt like I didn't know much about it at all. And even still now, you know, I didn't know much about it, even though I've been helping out over, I guess, the last semester. And then this semester, you know, I pretty much have done nothing for them, but now I'm taking the time to actually learn through React. So I've had like experience in the past with React only through exposure and not through actually learning a course. And then so now I'm just, I guess I see some of these things, such as the, what's this called, the decomposing, the prop destructuring, and now I actually have a term to understanding what this actually means. So, you know, like I see this in production code and I understand that we use that, but I never knew it. I only thought of this as like arguments to a function, as opposed to this being a whole prop and then it being destructured into different, I guess, sub-properties or whatever they're called here now. So I don't know now. But, you know, I would have thought, before I even read this whole thing, that this was just arguments to a function, which they are. But I just put a proper name to it now, which is prop destructuring. But yeah, it's because I had the previous experience that I feel more confident, you know, going through this kind of breezily. So yeah. I don't know where I was going with that actually. Okay, I barely know anything. Yeah, well, yeah. So I was basically, I didn't know anything either. And I stumbled across, I stumbled over a lot of code when we're doing the startup stuff. And yeah, it was a limiting factor for me back then, but you know, it doesn't take less than, honestly, it couldn't probably take less than a month to really just understand all this. Even if you didn't have a background knowledge with doing the startup stuff. But basically having exposure is like the biggest thing, because I had good exposure in the startup. Man, I don't even know. Yeah. I can't explain myself fully, I think I'm just blabbering now. Okay, how can we pass functions to a prop? Functions to a prop, we can use just the function name and don't put the 2 brackets around it. Yup. Okay, but let me read the passing props to components. And I guess also another thing is that's good is to always read documentation. Even before I knew I guess how to even write in the language that I was writing for the startup, you know, it was still React, but on top of it we also had this thing called Next.js, which was basically a framework on top of React. And with that actually comes its own difficulties because, you know, when you're first starting out doing front-end stuff, you're like, okay, this is Next.js, but is this also React? And why, you know, why is this also JavaScript or is this TypeScript? And then you're not even sure what is what because everything's just a glob, like a one thing. You just don't know which part is React, which part is Next.js. And then so I guess the next logical step that I took when I had that issue was to look at the Next.js docs. So yeah, there's docs for Next.js, there's docs for React, you know, we're literally in the docs for React here, but the Next.js docs, you know, nextjs.org, and then I'm like, all right, let me go to the docs. Oh, well, firstly, you know, I probably understand what Next.js is, just reading through the front page, and then either learn Next.js or get started. I think I first go to the docs, see what it's about in the introduction. Although it's a lot to read, like, docs are like one of the best learning tools to any framework, which makes sense. And then, you know, I actually did this whole learn Next.js module, so this is something else on top of the docs, which gives a more streamlined learning process, as opposed to just docs with like definitions and all this stuff. So, you know, each one of these frameworks would also have their own learn modules. You know, I'm using the Odin project to learn React, but technically I could use just the React's learn module, which is exactly what we're on actually right now on this. So definitely got what you're saying, something I've been getting to the gist of watching people like the Primogen. Oh yes, the Primogen. I think the Odin project does a decent job of introducing this type of learning. Learning by doing. Yeah, exactly. Yeah, something I've been getting the gist of watching people like the Primogen. Yeah, the Primogen is a good person to actually go to get an overview of stuff, I would say, because he has, you know, the industry experience and he just speaks non-stop as well. And because of that, it's actually a lot of information that you can just absorb from his speaking and getting his takes on things. Yeah, man, that legit same thing. I legit watch his videos, or I don't watch his streams, but I watch his like clips that he has. Like some of them go for 30 to 40 minutes nowadays. Just put that in the background as well, usually. If I'm like doing chores at home, you know, sometimes I've done that less recently, but you know, I still do that. It's not that I don't do them at all. But yeah, I do them more often than not. And then same thing with like cybersecurity stuff as well. There's, you know, there's people that have like cybersecurity commentary, like Some Ordinary Gamers. That's like an Indian YouTuber, but he's westernized, like he's American. He doesn't have an accent at all, actually. And there was somebody else named Mental Outlaw. So let me open these people up. Some Ordinary Gamers. This guy's a good guy to talk about. I mean, he's a gamer, I think. He started off as a gamer, and now a lot of his videos are just like commentaries on, I got my hands on the Windows Government Edition. And he talks about it. And a Windows Government Edition, I actually didn't see that video, but it's pretty nice. He talks about these Nintendo's legal action stuff. So it's still gaming stuff. And then he's also sometimes degenerate as well when he goes to the deep web. But then there's also Mental Outlaw. So I'm just pretty much talking about my favorite YouTubers now. But Mental Outlaw is a little bit more cybersecurity focused. The SSH critical vulnerability that happened like 2 days ago. I even got an email about that SSH vulnerability on my own servers that I have hosted on like Google, and one from my university server. And he talks about NVChad, which is the same Neovim config that I'm using right now. He's got, he talks about the government stuff quite a lot, actually. Tech and government, trying to, the FBI. He's a little bit, very privacy focused, I would say. And then there's also one Satanic, who is just a cybersecurity I guess news reporter is true, yes. So very cool people. And then this is all DDoS attacks, teenager hacked the world's biggest companies. Anyway, I watch pretty much all his videos that come out. Alright, back to it. Okay, so the props, you can pass the image, tags are predefined, but you can pass any props to your own components such as avatar. Here's how passing props to a component. Okay, if you have avatar, some props, pass props to the child component. Let's pass 2 props, person and size. If double curly braces after person confuse you, recall they merely an object inside the JSX curlies. JSX curlies is an object. Yep, makes sense. Now you can write. Now you can read the props inside the avatar component. Props inside the component, separated by comma inside this. After function lets you make like you would with a variable, and some logic in avatar that allows person and size props to render. And you're done. Now you can configure to render in many different ways with different props. Try tweaking it. Size. Let's see. 400. That's very huge. 40. 49. Oh good, pretty good. Pretty cool. Alright, props let you think about parent and child components independently. For example, you can change the person or the size props inside profile without having to think about the avatar uses them. Yep, similarly you can change how the avatar uses these props without looking at the profile. Usually you don't need the whole props object itself, so just structure it into individual props. Oh. Okay, so I got food now. I might eat that first, and I'll come back to this. So, yep, we'll call it. I'll get back in around 30 minutes. So, yeah, I'll put on some lo-fi music in the meantime. Alright, I am back. Thing is, I'll be headed to the gym later in about 30 minutes or so. So I'm gonna just finish that, but I'll keep the stream on and come back in about 2 hours for more coding. So for now though, I'll continue with this. Okay. Let's see. All right. See. Alright, yeah, it's this again. Alright. Usually you don't need the whole props object itself, so you'll just structure it into individual props. Okay. Oh, right, I'm just typing into Abyss. Props let you think about parents and child components independently. For example, you can change the person or the size props in profile without think about avatar use. Similarly, you can change how avatar uses props without looking at the profile. You can think of props like knobs. They can adjust. They serve the same role as arguments. Serve for functions. In fact, props are the only argument to your component. Props are the only argument to your component. React component functions accepts a single argument, a props object. Component functions. Ah. Damn. I understand. Okay, that's something to always remember as a definition. React component functions only accepts one argument, props. And you can destructure props if you want into multiple arguments. So those are the terminologies. Okay. Usually don't need the whole props object itself, so you destructure it into individual props. Exactly what we were talking about just before. Specifying your default value for a prop. If you want to give a default value fallback or when no value is specified, you can do it with a destructuring by putting an equal sign and the default value right after the parameter. Now avatar person is rendered with no size prop. The size will be set to 100. The default value is only used if the size prop is missing or if you have size equals undefined. But if you pass size null or size 0, the default will not be used. Okay, that's interesting. Undefined versus null versus 0. So here's the thing. This is like a JavaScript concept, surely. Undefined, null, and 0. I think 0 makes sense. Null and undefined. I guess you can think of it as undefined means it's not defined, obviously, and then null means it's none, but not undefined. Okay, folding props with the JSX spread syntax. Oh, yes, this is another thing that I wanted to understand better. Folding props with the JSX spread syntax. Okay, so sometimes passing props gets very repetitive. Right, so if there's nothing wrong with repetitive code, it can be more legible, but at times you may value conciseness. Some components forward all of their props to their children, like how this profile does with avatar. Because they don't use any of their props directly, it can make sense to use a more concise spread syntax. Wow, I really didn't consider this was just that simple. So ... props. This forwards all the profile props to the avatar without listing each of their names, using spread syntax with restraint. If you're using it in every other component, something is wrong. Often it indicates that you should split your components and pass children as JSX. Pass children as JSX. More on that next. Passing JSX as children. It is common to nest built-in browser tags. Sometimes you want to nest your own components the same way. When you nest content inside a JSX tag, the parent component will receive the content in a props called children. For example, the card component below will receive a child prop set to avatar and render it in a wrapped div. Let's see. Yeah, for sure. Try replacing the avatar inside card with some text to see how card component can wrap any nested content. It doesn't need to know what's being rendered inside of it. Then a component with a children prop having a hole that can be filled in. But as parent components with arbitrary JSX, you can often use the child prop for visual wrappers. How props change over time. Okay, the clock component below receives two props and its parent component color and time. The parent component code is omitted because it uses state, which we won't dive into just yet. Just change the color in the selected box below. Color, time. Okay. Blue. Green. This example illustrates the component may receive different props over time. Props are not always static here. The time prop changes every second and the color prop changes when you select another color. Props reflect the component's data at any point in time rather than only in the beginning. However, props are immutable, a term from computer science, unchangeable. When components need to change its props, for example in response to a user interaction on new data, it will have to ask its parent component to pass it different props, a new object. Its old objects will then be cast aside and eventually the JavaScript engine will reclaim the memory taken by them. Don't try to change your props. When you need to respond to the user's input, like changing the selected color, you will need to set state, which you can learn about. A component's memory. Wow, okay. That is true. Okay. Recap. To pass props, add them to the JSX just like you would with HTML attributes. To read props with the function avatar, nested JSX, props read-only snapshots. You can't change props when you need interactivity. You'd need to set state. Okay. Try out some challenges. Epic. Alright, we're good. So let me go back. You need to set state and not use props. Okay, good. Good. Okay. Nice. Let me quickly just respond. Yes. Alright. Nice. Okay. Parsing commutes, hacking with parse functions is okay, that's done. F, SJ, F, K. Introduction to state. Here we go. Here we go. We're learning about states now. Alright. Finally. Okay. Okay. Exciting application you can build is likely to change over the time the user exploring it. The changes could be as basic as toggle a drop-down menu or complex as fetching data from an API. React provides primitives to manipulate the state of the apps, more specifically components, to make them dynamic. In this lesson, we will learn how to use state in React. Read What is State by Academind before we get started. Whoa. My pages. I just went backwards. Wait. No, I didn't. What is state in programming? Okay. Maximilian Schwarzmuller. I can tell you for a fact, Academind, it's a fun fact actually. I know Academind. My brother used to work for this company as like a tutor. So pretty cool. Okay. State is a term where you encounter, learn, and develop. What is state? It's not a difficult concept, nor a React-specific one as it turns out. What is state? To understand what state is in programming, let's understand what the word state actually means outside of programming. If you're drinking, my current state is that I'm drinking coffee. Also, we could also narrow this down. It might be moving my coffee mug, the mouth, so the state is also holding the coffee cup, and I'm lifting up my mouth. My state also is that my mouth is opened. So state is not just one thing. As a person, you are constantly in a lot of different states depending on how you look at it. If you split it up as above, you can assign states to your different body parts. Mouth is open, or look at your overall state drinking coffee. And in programming, it's basically the same. In web application, the overall state might be that a modal overlay is displayed asking the visitor for input. That's the state of web application. Of course, we could split this into smaller parts. The state of the modal is that it's open. The state of the form is the modal. In the modal is that it's empty, and so on. With that in mind, React code like this should make a lot of sense. Set auth modal is open. Use state false. Open auth modal or the main page. You don't need to know React, no worries. And state, of course, also is not exclusive to React. As described above, it's a universal concept, not even exclusive to programming. No matter if you work in web dev, front end or back end with JavaScript, with a framework like React, Angular or Vue, or without one, you'll be working with state. Don't miss the video that belongs to this article. You are finding it at the top. You also can find it at the top of the page. But what is state? Undo. Okay, but what is state programming? Specifically as described, state is just really that the state of the current snapshot of the program is part of it, and therefore it translates blah 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 blah. I think that's not really true, but hopefully it's understandable because there's no reason to make. Okay, I'm gonna just say this is good. What about this one?
Hi and welcome to this video. In this video, we're going to have a look at the concept of state. Because in programming, especially also when working with front-end frameworks and libraries like React.
Okay, I don't need to watch this because right now I don't even have my headphones in. Ah man, I can't move them down. Reject all, accept all. Sorry about that. Alright. What is state? This section contains a general overview of topics so you can learn. How do you state in React? What happens when state changes in React? We write components in React, a lot of components, and many times we want them to undergo visual changes as a result of a user or computer interaction. For this purpose, a component needs to remember things about itself. This is where state comes in. State is a component memory. Let's take a look at how we can use state in our code. An app that changes background color based on the clicked button. Take your time reading the code as well as we'll jump right in. Okay, so that's the app. That's invite. Sorry, not vite, vite. Vite. It's pronounced vite. Apparently, by the way, apparently. Okay, so use state on button click. style, background color. Colors map your color. The button with all these properties. How does a function take a single prop? React component. React function component. A React component function takes a single prop, whereas this is not a React component function. Duh. Okay. Yeah. Okay. This is a button. This is just a normal HTML button. Okay. Let's think. Background color, if selected. So background color triple equals the color selected or not selected. Key color. On button click color. You have all these colors. Colors.map, yeah, all of these colors. Color. Okay. Okay. The adapter changes its background color based on the clicked button. Take your time reading the code. The useState hook. The useState hook is a built-in hook. We'll talk about hooks later. In React, that allows you to define state in a function component. It takes an initial value as a parameter and returns an array with two elements that we can destructure. An array with two elements, the current state and a function to update the state. State definition with useState commonly follows this pattern. Yes, const state value, set state value, useState, initial value. Adopted for our use case, background color, set background color, and initial color. So let's just see that, locate that here. So background color, useState colors 0, originally it's 0. Set background color. Style background color. Right. For the whole app, right? Okay, no problem. And that's the whole app right there. App.css. There's some CSS. Okay. An app that changes its background. If you want to make knowledge of React, you can, to some extent, understand what's going on. The background color state is defined with the hook when, then on every button click, then on every button we set up a click event with the handler that calls the set background color function with the correct corresponding value. Then magically the new color is applied to the background. Adding more state variables should be as easy as adding more use state calls. Great, you can now use state, but what's going on under hood? How does state work in React? Okay, let's hit you with some theory. In React, when a component state or props change, The component is destroyed and recreated from scratch. Yes, you heard that right. Destroyed. Ooh, okay. So, in React, when a component's state or props change, the component is destroyed and recreated. This includes variables, functions, and React nodes. The entire component is recreated, but this time the latest state value will be returned from useState. This process is called re-rendering. Re-rendering is a key feature of React that enables it to efficiently update the user's interface in response to change in the underlying data. When a state changes, okay, yeah. React reconciliation algorithm. The process of re-rendering generates a new virtual DOM tree, document object model tree. Okay. Okay, explain re-rendering with the example above. Oh, sorry, I'm still here. So the process of re-rendering generates a new virtual document object model tree. The virtual document object model is a lightweight representation of the actual document object model that React uses to keep track of the current state of the UI. React then compares the new virtual document object model tree to the previous one and calculates the minimal set of changes needed to update the actual document object model. This is the reconciliation algorithm. Explaining re-rendering with the example above, when set background color is called, our app component is re-rendered. Essentially, the component is recreated, which means the onButtonClick function and our div and buttons are recreated as well. You wonder, shouldn't the background color state be recreated as well? Well, React takes the responsibility of keeping track of the latest state and providing it to the component. React takes the responsibility of keeping track of the latest state and providing it to the component. Yeah, fair enough. The initial state value will only be used for the component's first render and ignored on subsequent renders. The initial state value is only used for the component's first render and ignored on subsequent renders. Makes sense. Okay, React will provide the latest value, recreated from scratch. This is whenever there is a change to the value, or when the props change in app. So this gets recreated, this gets recreated. Okay, I see. What we covered in this text is just a brief overview of a portion of React internals. You may be curious to learn more, but be advised, this is a deep rabbit hole. What we covered above is enough to get you through the React course. Okay, that makes sense though. Okay, hooks. Hooks are functions that let you use React features. All hooks are recognized by use prefix. UseState is a hook. We'll use more of these as we get further into the course. For now, remember the hooks have rules that we need to abide by. Hooks can only be called from the top level of a function component. Hooks can't be called from inside loops or conditions. So at the top level of a functional component. Read the following articles from the React docs. So state a component's memory, render and commit. Okay. Read the article on React reconciliation algorithm for a great explanation. Okay, head back to the color changing background example from earlier in the lesson and a new state variable to keep track of the number of times the background color has been changed. The number of times the background color has been changed. Ooh. Hello TT. My friend, what project is this to set up Python code and VS Code? I see. I think I kind of understand what you're saying. So if you want to set this up, if you're talking about, wait, hold on, give me a second. I'll tell you in a bit. Actually, wait. I think I can still tell you a little bit more. But basically, if you're talking about the scheduler, there's a bit that you need to read, but if you want to build this whole app or use this as a clone for your own app, you can. But I took this from the original template, which was from Tiangolo, which is a full stack fast API template. So you got that Python code, and technically this is everything you need. You just need to read through the README, and it goes through a lot. So just take your time with it, actually, because this takes a lot of time to understand. But once you have all this, you can start the backend development, the front end development. This all is tailored to VS Code. I have VS Code on my left here, but sometimes I like to use Neovim. So yeah, right now I'm not using Neovim, but VS Code. And yeah, you can just follow these docs. But yeah, that's all I'm gonna say to that. Alright, I'll be right back. Okay, I'm back, but I only will be here for around 10 minutes and then I'll be off, but I'll keep the stream on. Okay. Hooks. Knowledge check. What is state? Yeah, what is state? Well, I mean, is there a way to express it in words? You know, state is just using useState, it seems. What is useState hook and how do you use it? Well, it returns two objects in a list. Ooh, that's actually something to remember, the terminology here. So useState is a built-in hook. The state and function takes an initial value as a parameter and returns an array with two elements that can be destructured to get the current state value and a function. So a value and a function. So what are some rules for hooks? What happens to a component when one of its states is changed? Then it gets re-rendered. What are some of the rules for hooks? They have to be not within an if-else block, I think. Cannot be called inside loops and conditions. It can only be called from top level of a function component. Read the following articles from the React docs. State a component's memory, render and commit. State a component's memory, render and commit. Article on React reconciliation algorithm. And changed. Display this number, the number of times the background color has been changed on the page. You'll need to fork the code sandbox to do this, which requires a code sandbox account. Okay. I will do this. Yeah, I will do this. State a component's memory. Yeah, it's going to be a lot of reading. This is also a lot. Okay. And then I'll also do that assignment as well. Okay, there's 3 assignments that I got to do. Okay, let's do one of them which is to read state of components. Yep. Okay, state of components memory. Components often need to change what's on the screen as a result of interaction. Typing into the form should update the input field. Clicking next on image carousel should change what image is played. Clicking buy should put a product in the shopping cart. Components need to remember things. In React, this kind of component, specific memory is called state. You'll learn how to add a variable using the useState or pair of values the useState hook returns. How to add more than one state variable, why state is local. How to add more than one state variable. Why state is local. When a very regular variable isn't enough. Sculpture list. Let index equals 0. Index plus minus 1. Sculpture list index. Index of sculpture list length. Data.js. Name, artist, description, URL, alt. Right. Just a basic array doesn't work. Because it's getting re-rendered, potentially. And let index 0 is always just going to be 0 when it gets re-rendered, I think. I think that's how they're going to frame it. Because state is not being saved. Because the whole component, the gallery component, is cannot be anything else but what it currently is. Okay. The handle click event handler is updating a local variable index, but two things prevent the change from being visible. Local variables don't persist between renders. When React renders this component a second time, it renders it from scratch. It doesn't consider any changes to the local variables. Changes to local variables won't trigger renders. True, okay. Changes to local variables don't trigger renders. React doesn't realize it needs to render components again with the new data. To update a component with new data, two things need to happen. Retain the data being rendered. Trigger. React to render the component with new data, re-rendering. useState hook provides those two things. A state variable to retain the data being rendered. A state setter function to update the variable and trigger React to render the component again. Adding a state variable. To add a state variable, import useState from React. Then replace that with this setter function. It's called the array destructuring. It lets you read values from an array. So it's array destructuring versus, I guess, object destructuring is another one. This is how they would work together in handle click. Use state. Perfect. Alright. Meet your first hook. In React, use state. Let's see. In React, useState as well as other functions start with use to call a hook. Hooks are special functions that are only available while React is rendering, which we'll get into more detail on the next page. They will let you hook into different React features. State is just one of those features, but you'll meet the other hooks later. Hooks are special functions that are only available while React is rendering, which we'll get in more detail next page. They let you hook into different React features. Hooks. Functions start with use, can only be called at the top level of components, or your own hooks. You can't call hooks inside conditions, loops, or other nested functions. Hooks are functions, but are helpful to think of them as unconditional declarations about components' needs. Unconditional declarations about components' needs. You use React's features at the top of the component, similar to how you import modules at the top of your file. Okay, fair enough. Anatomy of a use state. In this case, you want React to remember index. The convention is to name this pairing like something and set something. You can name it anything you like, but conventions make it easier to understand across projects. The only argument to use state is the initial value of your state variable. In this example, the index initial value is set to 0 with use state 0. Every time your component renders, use state gives you an array containing 2 values: the state variable index with the value you stored, the state setter function, which can update the state variable and trigger React to render the components. Here's how this happens in action. You set the index to 0, your component renders the first time because you're passing 0 to use state as the initial value for index. It will then return 0 set index, remembers 0 as the latest state value. You update the state when a user clicks a button, set index plus 1, index is 0, so it's set index 1. This tells React to remember index is 1 now and triggers another render. Your component's second render, React still sees use state 0, but because React remembers that you set index to 1, it returns 1 set index instead, and so on, giving a component multiple state variables. This component has 2 state variables, a number index and show more. This is a toggle where you can show more details. And it states it's a good idea to have multiple state variables if the state is unrelated. This example, but if you find often change 2 state variables together, it might be easier to combine them into one. For example, if you have a form with many fields, it's more convenient to have a single state variable that holds an object than state variable per field. Read choosing the state structure for more tips. Choosing use state, handle more click. Oh, okay. TTT. I mean TTTT. I keep on messing your name up, but are you subscribe with you because every day I will learn with you in my computer. Well, I take I take that very sentimentally. Thank you for your kind words, TT. Okay. Let's see. So I wanted to just make sure I understand. sculpture length, sculpture artist. On click, you either hide or show. That's what it show or hide details, and then this is using a ternary operator using JSX argument, and this is a similar thing using JSX arguments. No ternary operators, but okay. If show more is true, and this, so that and you can do, because when show more is true, then it shows whatever is in the second argument or second position to the double and symbol. Epic. Okay. It's a good idea to have multiple state variables if state is unrelated. Yep. So how does React know which state to return? How does React know which state to return? Okay, you might have noticed that useState does not receive. Oh, actually. State in isolation and in private. A recap. Okay. Okay, state in isolation and in private. All right, let's finish this whole section, and then yeah, we might be able to also do this next part as well. Okay. You might have noticed that the useState does not receive any information about which state variable it refers to. That's true. There's no identifier that is passed to useState. So how does it know which are the state variables to return? Does it rely on some magic, like passing a function? The answer is no. Instead, to enable their concise syntax, hooks rely on a stable call order on every render of the same component. This works well in practice because if you follow the rule above, only call hooks at the top level, hooks will always be called in the same order. Additionally, a linter plugin catches most mistakes. Internally, React holds an array of state pairs for every component. It also maintains the current pair index, which is set to 0 before rendering, each time you call useState. The current pair index. Each time you call useState, React gives you the next state pair and increments the index. You can read more about this mechanism in React hooks. Not magic, just arrays. Just arrays. If it's just arrays, then that also makes sense for why you can't use hooks in conditionals or in for loops. Although for loops, I mean, it could somewhat make sense still, but I mean, that's alright. But conditionals, because, you know, then it breaks an array processing the data in order. Internally, React holds an array. Yep, okay. This example doesn't use React, but it gives you the idea of how useState works internally. Not using React. This is just JS. Oh wow, this is going to be long. How do you don't understand, you don't have to understand it to use React, but you might find this a helpful mental model. So this is the same implementation. Alright, let's have a look. Component hooks equals empty. Current hook index is equal to 0. How useState works inside React. Function useState. Initial state. Oh, right, so this is still use state, this is still use state. And all of this is still arguably the same thing. Same functions that we saw before. Okay, and then update DOM, let output gallery. Yeah, so this is all the outputs from here being displayed here in the update DOM, which is just being updated every time. Well, it's just being updated in one scan. Current hook index before rendering the component. Ooh, I see. Next button, document get element by ID. Let next button, let header, let more button, description, image, sculptures, list. And then you update the DOM, make UI match the initial change. Update DOM. This is index.js, I see. This is use state, pair component hooks. If pair, this is not the first render, so the state pair already exists. Return it and prepare it for next hook. Current hook index adds. It's not the... This is not the first render, so the pair state already exists. Yep. Otherwise, this is the first time we're rendering, so create pair and store it. Set state, when the user requests a state change, put the new value into the pair. Yep. Pair 0 is next state. Update DOM. Store the pair for the future renders. Sure. And then gallery is just gallery, right? We talked about that. And then index HTML. The button with the next. Header. ID with more button, ID with description, ID with image. The style as it is. Damn. HTML. That looks like HTML to me. Okay. Yeah, definitely. I mean, that whole section probably took another 5 minutes. Yeah, it did. Okay. I'm gonna say then, I'll probably finish reading this part and then I'll be good. State is isolated and private. State is local to a component instance on the screen. In other words, if you render the same component twice, each copy will have completely isolated state. I see. The gallery component from either of them. There's no changes to its logic. Try clicking the buttons inside each of the galleries to notice the differences. Yeah? Okay, let me read this and then I gotta head off. This is what makes state different with regular variables that you might declare at the top of your module. State is not tied to a particular function call or a place in the code, but it's local to the specific place on the screen. You render two gallery components, so the state is stored separately. Also notice how the page component doesn't know anything about the gallery state or even whether it has any. Unlike props, state is fully private to the component declaring it. The parent component can't change it. This lets you add state to any component or remove it without impacting the rest of the components. If you want both galleries to keep their states in sync, what if you want that? The right way to do it in React is to remove state from the child components and add it to the closest shared parent. The next few pages will focus on organizing state of a single component, but we will return to the topic of sharing state between components. Alright. Some challenges. Complete the gallery. Fix stuck form inputs. Okay, fix a crash. And remove unnecessary state. These are good examples to try. Given the time that I have, I might just pause it for now, and I'll come back to this in about an hour and a half to 2 hours. All right. So let's say around 4:15. I'll be back around 4:15. So 4:15. I'll just make a note here. And yeah, see you guys in a bit. Alright, we're back. That was actually a little longer than expected, by about 30 minutes longer. Actually, as soon as I got home, had a shower as well. So, I'm not a stinky programmer. You know how it is. Alright. Jatin Gamer messaged as well. He said, "Good to see you again. David, keep it up." Thank you. Thank you, man. I really appreciate it. Not sure if you're long gone already, but it'll be recorded. Alright. Let's see, try out some challenges. Alright, try this one, complete the gallery. Okay, before I do, just want to save something real quick. Okay. Let's see, complete the gallery. When you press next on the last sculpture, the code crashes. Fix the logic to prevent the crash. You may do this by adding extra logic to event handler or by disabling the button when the action is not possible. After fixing the crash, add a previous button that shows the previous sculpture. It shouldn't crash on the first sculpture. Okay, so hold on, let's see. Sculpture is undefined. Okay, disabling the button when it's not possible. Handle next click, index increment. Sculpture list. Sculpture list. Let's see. Handle next click. Handle more click. Set show more. I gotta turn off notifications. How do I turn off notifications? Do not disturb. Okay. Handle next click. Use state, index and set index. Use state 0. Use state false. Show more. Set show more. So we need to prevent when you press the next on the last sculpture, the code crashes. Fix the logic to prevent the crash. You may do this by adding extra logic to event handler or by disabling the button when the action is not possible. Disabling the action when the event is not possible. Button disable. Disable. True or false? Is disabled. Okay. That's fine. And disable is disabled. So if sculpture list dollar just dot length. Index. I see. Close the bracket. If index is equal, if index is equal to sculpture list dot length, space. Nope, that's yes. If this then is disabled equals true. Ooh, man, I just did the rookie mistake. Set is disabled to true. Let's have a look. Oh, for non-boolean attribute disabled. Disabled is a non-boolean attribute? Okay, fair. If you want to write it to the DOM, put a string instead. Put a string instead. Or value toString. Value or undefined. Oh yeah, I suppose you could. Is disabled? No, just if ternary operator. Sculpture and sculpture length index and true. Still get the error. Disable true. Undefined. Oh, I put it in the wrong thing. Did I? Yes, I did. On click. Sculpture list. Sculpture list. It's a bit finicky, but you know. How to disable a button. Disabled. Disabled. I wonder. Is this even right? I don't know. Just have to see. Pointer 3. Oh, look at that. I figured it out. Wow. What about it was undefined? Fixed stock form input. The value of the first input is set to always match the first name variable, and the value for the second input is set to always match the last name variable. This is correct. Both inputs have onChange event handlers, which try to update the variables based on the latest input. However, the variable doesn't seem to remember their values between re-renders. Fix this by using states. Makes sense. If only this was in Vim. First name. Use state is not defined. Yep, you can't just set it like this. You have to, after all, put curly brackets, brackets around this. Ooh, I am loving this. Here's a small form that is supposed to let the user leave some feedback. Hold on, I want to see this one. Form input, input, H1 button. Form, on submit, prevent default. One click, handle reset. Hi, first name, last name. Handle first change, on change, right. Use on change. Okay. Fix a crash. Fix a crash. Here's a small form that is supposed to let the user leave some feedback. When the feedback is submitted, it's supposed to display thank you message. However, it crashes with an error saying rendered fewer hooks than expected. Can you spot the mistake and fix it? Rendered fewer hooks than expected. This may be caused by an accidental early return statement. Okay. Very well. Undo. Control C. Does that really mess with anything at all? No, we're good. Remove unnecessary state. The button clicked this example should ask the user's name and then display an alert greeting them. Try to use state to keep the name, but for some reason it always shows hello. Remove the unnecessary state variable. We'll discuss why this didn't work later. Explain why the state variable is unnecessary. Hello. Nothing. I'm guessing it got rubbished already. Or it got sent to the rubbish bin already. Oh, whoops. Oh, name. I think I know why. I think it's because it got... Oh. I forgot to remove this. Okay. I think it's because it gets sent to garbage before it can even render the alert. Or it gets nulled, right? So then you just see nothing there. Or not nulled, undefined. It gets created as undefined. Okay, and then so that part is done. Now we've got to think about render and commit. Before your components are displayed on screen, they must be rendered by React. Understanding the steps in this process will help you think about how your code executes and explain its behavior. You'll learn what rendering means in React, when and why React renders a component, the steps involved in displaying a component on screen, why rendering does not always produce a DOM update. Document object. Document object. Something. Keep on forgetting. Model. Before your components are displayed on screen, they must be rendered by React. Understanding the steps in this process will help you think about how your code executes and explain the behavior. What rendering means, what and why why React renders a component, steps involved in displaying a component on screen, why rendering does not always produce a DOM update. Imagine that your components are cooks in the kitchen, assembling tasty dishes for your ingredients. In the scenario, React is the waiter who puts in requests. Okay. And brings them their orders. This process of requesting and serving UI has 3 steps. Triggering a render, delivering the guest order to the kitchen, rendering the component, preparing the order in the kitchen, rendering the component, preparing the order in the kitchen, committing. It's to the DOM. Render and commit, I see. Placing the order on the table. Trigger, render, commit. Trigger a render. Okay, hold on. Let me think about this for a second. This is good information that I do want to keep a hold of. So I'm gonna start putting this information that I've gathered not in working memory, but instead in theoretical written text. Okay. Now the problem is, I haven't set up Obsidian on this device, on this laptop, on this desktop. So I'm gonna just be typing on my laptop. Actually, you know what, like legit, all I'm doing is just writing the thing so I know it's there. Not necessarily that I will explain it or write it in my own words. It'll just be when I look at it again, if I don't know what render and commit is next time, then I can come back to this link and figure it out again. So render and commit. I was just finding a page. Okay, done. Okay, trigger a render. There are two reasons for a component to render. It is the component's initial render. The component's or one of its ancestors' state has been updated. One of its ancestors. When your app starts, you need to trigger the initial render. Frameworks and sandboxes sometimes hide this code, but it's done by calling create root. Create root with the target DOM node and then calling it render method with your component. Root render image. Get element by ID root. Create root. This is kind of similar to one side of the page here. So if I got index .html, you got an ID root, and you have the main.tsx. Create router. I see. Create. Okay, here we go. Yeah. React DOM create root with the root. Okay, that's very interesting. I don't know what that means. And then render image. And in our case, we're rendering strict mode. Okay, but what then is this bang symbol, you know? This is where inline Copilot can help. Explain this. React document object manager is a method provided by React DOM package which is used in React applications to interact with the DOM, document object model. In React 18, create root is used to create a root container where the create elements will be rendered. This is a change from previous versions of React where render was directly used. Document get element by ID root. This part of the code is vanilla JavaScript and not specific to React. It is used to select a HTML element with the ID of the root. Typically in a React application there is an index HTML with a div element that has an ID of root. This div serves as the entry point for the React app, meaning that the entire application will be rendered inside this div. Epic, just one div, you know, like think about that, one div is all it takes to render the rest of your project. It's like files and folders, I mean, you know, like you can have one folder that contains many other folders inside it. Okay, number 3. The bang symbol. This is where I was confused. The exclamation mark is a TypeScript non-null assertion operator. It tells TypeScript that you're sure document.getElement by ID root will not return null. This is necessary because getElement by ID can return null if no element with the specified ID exists in the document. However, in the context of a React app, you're typically in control of the HTML and can ensure that an element with the ID root does exist. The non-null assertion operator prevents TypeScript from throwing an error about possibility of a null value. Damn, okay, so this is also something I just want to copy down and save. Only problem is I can't send this anywhere, so I'm going to rewrite this a little bit. I'm going to rewrite this a little bit on my device on the side here. Give me a second. Non-null assertion, is that right? Operator. Okay, nice. I just wrote that to the side. Yep, very interesting. And render is the method that calls. This is a summary of lines of code, blah blah blah. Okay. Try commenting out the root render and see whether that the components disappear. Re-renders when state updates. Once the component has been initially rendered, you can trigger further renders by updating its state with the set function. Updating your component state automatically queues a render. You can imagine these as a restaurant guest ordering tea, dessert, and all sorts of things after putting in the first order, depending on the state of their thirst or hunger. State update. Yep, triggers React, which React from your components renders. Okay, React renders your components. After you trigger a render, React calls your components to figure out what to display on screen. Rendering is React calling your components. On initial render, React will call the root component. For subsequent renders, React will call the function component whose state update triggered the render. This process is recursive. We'll call the function component whose state update triggered the render. After you trigger a render, React calls your components to figure out what to display on screen. React will call the function component whose state update triggered the render. Yeah, makes sense. This process is recursive. If the updated components return some other component, React will render that component next, and if the component also renders something, it will render that component next, and so on. The process will continue until there are no more nested components and React knows exactly what should be displayed on screen. In the following example, React will call gallery and image several times. During the initial render, React creates the DOM nodes, for section, h1, and image tags. During the re-render, React will calculate which of their properties, if any, have changed since the previous render. It won't do anything with that information until the next step, the commit phase. Pitfall. Rendering must always be a pure calculation. Same inputs, same outputs. Given the same inputs, a component should always return the same JSX. When someone orders a salad with tomatoes, they should not receive a salad with onions. It minds its own business. It should not change any objects or variables that existed before rendering. One order should not change anyone else's order. Otherwise, you can encounter confusing bugs and unpredictable behavior as your codebase grows in complexity. When developing in strict mode, React calls each component's function twice, which can help surface mistakes. Caused by impure functions. Strict mode, not bad. Alright, that's why we have a strict mode here. Okay. Optimizing performance. The default behavior of rendering all components nested within the updated component. is not optimal for performance if the updated component is very high in the tree. If you run into a performance issue, there are several opt-in ways to solve it described in the performance section. Don't optimize prematurely. Makes sense. I agree. Never optimize prematurely. Okay, step 3. React commits changes to the DOM, to the document object model. After rendering your components, React will modify the DOM. For the initial render, React will use the append_child DOM API to put all the DOM nodes it has created on screen. Append_child DOM API, is that part of, let's see, Mozilla? Yeah, okay. Alright, and then for re-renders, React will apply the minimal necessary operations calculated while rendering to make the DOM match the latest rendering output. React only changes the DOM nodes if there is a difference between renders. For example, here's a component that re-renders with different props passed from its parent every second. But the text doesn't disappear when the component re-renders. This works because during this last step, React only updates the content of h1 with a new time. It sees the input appears in the JSX in the same place as last time, so React doesn't touch the input or its value. Browser pane. Epilogue. After rendering is done, React updated the DOM, the browser will repaint the screen. Although this process is known as browser rendering, we'll refer to it as painting to avoid confusion throughout the docs. Okay, the browser takes a painting of the food. Any screen update in a React app happens in 3 steps: trigger, render, commit. You can use strict mode to find mistakes in your components. React does not touch the DOM if the rendering result is the same as the last time. Read the article on React reconciliation algorithm for a great explanation. Okay. Reconciliation is the process in which React updates the UI to reflect changes in the component state. The reconciliation algorithm is the set of rules that React uses to determine how to update the UI in the most efficient way possible. React uses a virtual DOM to update the UI. The virtual DOM is a lightweight in-memory representation of the real DOM, which allows React to make changes to the UI without manipulating the actual DOM. This makes updates faster, as changing the virtual DOM is less expensive than changing the real DOM. The reconciliation algorithm works by comparing the current virtual DOM to the updated virtual DOM, and making the minimum number of changes necessary to bring the virtual DOM in line with the updated state. The algorithm uses two main techniques to optimize updates. Tree diffing. React compares the current virtual DOM tree with the current virtual DOM tree, with the updated virtual DOM tree, and identifies the minimum number of changes necessary to bring the virtual DOM in line with the updated state. Batching. React batches the multiple changes in a single update, reducing the number of updates to the virtual DOM and in turn the real DOM. The reconciliation algorithm is a critical part of React's performance and helps make React one of the fastest and most efficient JavaScript libraries for building user interfaces. After the reconciler compares the current and updated virtual DOM, it identifies the difference and makes the necessary changes to the virtual DOM to bring it in line with the updated state. This updating of the virtual DOM is done for several reasons: to keep the virtual DOM as accurate representation of the current state of the components so that it can be used in future updates. To optimize updates to the real DOM, the virtual DOM provides a way for React to make changes to the UI without manipulating the real DOM directly. By making changes to the virtual DOM, React can determine the most efficient way to update the real DOM and make only the minimum number of changes necessary. To ensure that UI remains in sync with the state of the components, the reconciliation process ensures that the virtual DOM accurately reflects the current state of the component so that UI remains up to date and in line with the state of the application. In summary, the reconciler updates the virtual DOM after the reconciliation process to keep it accurate, optimizes updates to the real DOM, and ensures the UI remains in sync with the state of the components. Please let me know your views too. Why does this sound GPT? I can't help but feel like some of this is GPT. Sure, that looks good. Alright, so head back to the color changing background example from earlier in the lesson. Add a new state variable to keep track of the number of times the background color has been changed. Display the number of times when the background color has been changed on the page. You'll need to fork the code box to do this, which requires a code box account. Click Open Editor in the top right of the code box embed, then fork in the top right of the editor. There's no other option. Okay. Okay. Ooh, I didn't know I could just change it like that, actually, damn. Enable VS Code Web. Nah. Okay. You want me to head back to the color changing background example from earlier in the lesson, add a new state variable to keep track of the number of times the background color has been changed, display the number of times it has been changed on the page. Easy. Hello world. Gonna do some JSX. Pink, green, blue, purple. Set background color. Set change. Change +1. Plus? Does that work? Change ++ does not work. +1. All goods. Pretty good. I like it. I am very knowledgeable now. And I feel like I can move on to the next stage of what I want to do. Okay, this is more on state. I might actually want to go through all this. But let me see the course real quick. Introduction to state, more on state, how to deal with side effects. Class-based components, component lifecycle methods, introduction to React testing. More on states. Maybe I want more on states. Before I fully continue to my nav bar. Classes. REST parameter classes implicitly has an any type. Classes dot filter boolean join class names. There's a function item current. Oh my god. Maybe I need to transform some of these to using, I think, CN as opposed to class names. I think. Aria current. Implicitly has the any type, which is not good because we're talking about TypeScript. How to structure state, how to update state, and learn about controlled components. Controlled components contains a general overview of topics that you will learn. How to structure state. Managing and structuring state effectively is by far one of the most crucial parts of building your application. If not done correctly, it can become a source of bugs and headaches. The assignment items go through the topic thoroughly, but as a general rule of thumb, don't put values in state that can be calculated using existing values. But as a general rule of thumb, don't put values in state that can be calculated using existing values, state, and or props. But in general, don't put values in state that can be calculated using existing values, existing state, or existing props. Okay. State should not be mutated. Alright, hold on, let me turn on some lights here. Okay. States should not be mutated. Mutating state is a no-go area in React as it leads to unpredictable results. Primitives are already immutable, but if you are using reference type values, arrays, and objects, never mutate them. According to the React documentation, we should treat state as if it were immutable. To change state, we should always use the set state function, which is the case of the example below in the setPerson function. Bad, don't do this. Person age is equal to person age plus 1. setPerson. Oh, really? I see. Good, you want to do this, which is const new person, where you got all of the props of person. So this is called, there was a word for it that I learned just before during the day today. I'm gonna go back and find it. Age, person age plus 1. So just always create a new value. It's called property something. Okay, because I want to write this down as well. Property state. Hold on. Give me a second, guys. Okay, I am back. Let me move up my table. Very interesting. State should not be mutated. Yeah, and the 3 ellipses, what is 3 ellipses called? What is ... in JavaScript? Control F ... The spread operator. Okay, the spread operator is what it's called. Should not be mutated. Spread operator. ... Ugh. Okay. Okay. Alright. That's a spread operator, the in operator. Yeah, it doesn't matter. What am I looking at this? Okay, so the spread operator on person, and then you update the age, basically. Age gets updated to person age plus 1. And person.name, person.age, increase age. When you handle increase age. Okay, objects and arrays and states. In the above example, notice how we create a new object and then copy the existing state into the new object while providing a new state for age. This is because we don't provide a new object to set state. It is not guaranteed to re-render the page. If we don't provide a new object to set state, it is not guaranteed to re-render the page. Therefore, we should always provide a new object for set state to trigger a re-render. Set state uses object.is to determine if the previous state is the same state. Set state uses object.is. Wow, okay. As for nested objects and arrays, a state can get tricky fast, since you will have to copy the nested items as well. Be careful when using them. How state updates. State updates are asynchronous. What this implies is that whenever you call the setState function, React will apply the update in the next component render. Let me read that again. So setState updates are asynchronous. Whenever you call setState, React will apply the update in the next component render. This concept can take a while to wrap your head around. With a lot of practice, you will get the hang of it in no time. Remember, state variables aren't reactive. The component is. This can be understood by the fact that calling setState re-renders the entire component instead of just changing the state variable on the fly. State variable on the fly. So these are the logs for this person state. John, age 100. Handle increase age. Set person. And in handle increase age before set person is that person. We can call set person. Surely person has updated, right? This console runs every time the component renders. What do you think this will print? Well, surely this prints 101 and the 2 before it prints 100. 100, 101. Is 100. During render is 101. During render is 100. These other logs. What's happening? Let's break it down. Ignore the double console logs for the render case. This is covered in the upcoming lessons. I bet this double render is strict mode. Probably. The component renders the first item. The person state variable is initialized. The during render console log prints the state variable. The button is clicked invoking handle increase age. Interestingly, the console log before and after the set person called prints the same value. The component re-renders. The person state variable is updated to John age 101. The person state stays the same throughout the current render to the component. Current render of the component. Throughout the current render of the component. This is what state as a snapshot refers to. The set state call triggers a component re-render, and the person state is updated to the new state, to the new value. The unexpected infinite loop. The following is an infinite loop. Can you guess why? Drop it by the top Discord server. The Odin Project Discord server. Tell us why and score a brownie point. Is that really something that you can do? To drop by? Yeah, I have an account already. I'm already here. Tell us why. And score a brownie point. Well, set count, count plus 1. Okay, so const this whole thing. Set count plus 1. Return count. Oh my. You render count. And then when you render count, set count gets called, which means it gets re-updated. And then it keeps on going and going and going. Yeah, that makes sense. State updater functions. A trick question. Let's look at another implementation of handle increase age. What do you think it does? Handle increase age. Surely it would increase by the age too? Nope. The above code is saying to React, hey, replace the current person with an increase by 1, then replace the current renders person with an age increased by 1. Notice the word replace. When you pass in a variable to the set state function, React will replace the current state with a value passed. You might be wondering, what if I want to update the state multiple times using the latest update? This is where the state updater function comes in. The state updater function. Yo. Prev person. Wow, okay. State updater function. That's actually crazy. Okay, when a callback is passed to the set state function, it ensures that the latest state is passed in as an argument to the callback. When a callback is passed to the set state function, it ensures that the latest state is passed in as an argument. Passed in as an argument to the callback. Using an updater is not always necessary. If you want to change the state using your previous state, and you prefer consistency over verbosity, then you might consider using an updater. React batches state updates. There are two set person calls in the above example. And from what we've learned so far, a set state call triggers a component re-render. So the component should re-render twice. You would say yes, but React is smart. Whenever possible, React batches the state updates. Here the component only re-renders once. We'd encourage you to use console log to verify this. There's nothing smart. It's just programming. And the real smarts are the people who make it. Controlled components. There are native HTML elements that maintain their own internal state. The input element is a great example. You type in an input and it updates its own value on every keystroke. For many use cases, you would like to control the value of an input element. Set its value yourself. This is where controlled components come in. Damn. I kind of get it now. Set value, event target value. You control the component input because the input has its own value. Instead of letting the input maintain its own state, we define our own state using the useState hook. We then set the value prop of the input to the state variable and update the state variable on every onChange event. Damn, okay, hold on. Let me think about this. Instead of letting the input maintain its own state, we define our own state using the useState hook. We then set the value prop of the input to the state variable and update the state variable on every onChange event. Now every time the user types something in the input, React will ensure you have the latest comment, review, or post, whatever the user was typing in value. The pattern is extremely useful whenever you need user input, typing in a text box, toggling a checkbox. Contrarily, yes, the input element can be left uncontrolled and access its value through some other method. You don't need to worry about it yet, as it will be covered later in the course. For now, control your components. Okay. That last part on controlled components is kind of good, kind of big. I'm gonna have to save that section on my other device here. Spread operator controlled. Input tag example for control components. With controlling for controlled component input components. Okay. And the state updater functions. A trick question. Let's look at another implementation of handle increase age. What do you think? Surely it increases the age by 2. Nope, the above code is saying to React, hey, replace the current renders person with an increase in age by 1, then replace the current renders person with an increase in age by 1. Notice the word replace. React will replace the current state with the value passed. You might be wondering, what if I want to update the state multiple times using the latest state? This is where the updater function comes in. State updater function. State updater functions. More gotta keep that right in my hands. Right in my hands. Alright, finally. Okay. Finally, let's go to the assignment. Knowledge check. So the following questions are an opportunity to reflect on key topics in the lesson. If you can't answer, yep. What should you keep in mind while declaring state? What should I keep in mind while declaring state? I don't know. Okay. I can eat dinner now, so I'll be right back. Okay. What have I missed, if anything? Let's see. Ooh, okay. Oh, TT's back. I'll subscribe with you because every day I want to learn in my computer. Thank you. Thank you, TT. Hopefully you will learn a lot. Yeah. Alright. Sorry guys, I just had dinner, so I'm back. Okay. Let's see. So I was on the knowledge check. What should you keep in mind while declaring state? Mutating state. You can't mutate state. Yep. Fair enough. That's fair enough. Why should we always use set state to update our state? We should always use set state because without it we wouldn't be able to update components. And you know, set state is a way to trigger React to update or to render the components. What state as a snapshot? What does state as a snapshot mean? Okay. What does state as a snapshot mean? State as a snapshot, well, when there's a use state in a component, it doesn't get updated in that component, but it gets updated on the next instance when it runs through that component. So throughout the whole component, it's a snapshot of the state and you can't really update it. So what is the difference between passing a value versus a callback to the set state function? So the difference between passing a value and a callback. So a value to set state will set the value for that state versus a callback to the function. A callback would execute the set state immediately or synchronously, I should say. And I think that's it, right? Let me think. Uses a callback, right? Instead of a callback function instead of a value. So I guess another thing is, what is a callback function? You know, like, let's define that more explicitly. Callback function. JavaScript callbacks. Okay, so a callback, I will call back later. A callback is a function passed as an argument to another function. Is a function passed as an argument to another function. This technique allows a function to call another function. A callback function can run after another function has finished. JavaScript functions are executed in the sequence that they are called, not in the sequence that they are defined. Yep. And sequence control, JavaScript callbacks. Alright. Sorry, that was my parents. Okay. So when to use a callback. No, that's fine. I can close that. Let's see. Why should we always provide a new object to set state? Because there is no guarantee that the previous object, when it gets updated, will also re-render the component. And not only that, you shouldn't be mutating objects in the first place because of that reason. But yeah, why should you want to control a component? We can control a component. We want to control a component so that we can get more control of it, I suppose. I mean, you know, I'm thinking of the example of the input tag, but let's have a think further. That maintain, you may type in arguments, control the value, set its value yourself. I guess, yeah, you want to set the value yourself rather than let input handle that functionality. Yeah, as simple as that. Okay. Oh, not exactly complete because I need to do these. Okay, state as a snapshot. Okay. State as a snapshot. So state variables might look like regular JavaScript variables that can read and write. State variables might look like regular JavaScript, but that you can read and write to. However, state behaves more like a snapshot. Setting it does not change the state variable you always have, but instead triggers a re-render. You'll learn how setting state triggers re-renders, when and how state updates, why state does not update immediately after you set it, how event handlers access a snapshot of the state. Okay. Oh, hello Nib. Nib has arrived. The 3 cat symbols in a box, they're Schrodinger's kitties. Setting state triggers renders. Yep, you might think of your user interface as changing directly in response to the user event, like a click. In React, it works a little differently for this mental model. On the previous page, you saw that setting state requests a re-render from React. This means that for an interface to react to the event, you need to update the state. In this example, when you press send, set is sent true tells React to re-render the UI. Hi, send. Your message is on its way. And in this example, use state, is sent, your message is on its way, return, otherwise you return the on submit, on change, set message, function send message. Here's what happens when you click the button. On submit, event handler executes, set is sent to true and queues a new render, re-renders the component according to the new is sent value. Let's take a closer look at the relationship between state and rendering. Rendering takes a snapshot in time. Yep, means that React is calling the component, which is a function. The JSX you return from that function is like a snapshot of the UI in time. Its props, event handlers, and local variables were all calculated using its state at the time of the render. Unlike a photograph or a movie frame, the UI snapshot you return is interactive. It includes logic like event handlers that specify what happens in response to inputs. React updates the screen to match this snapshot and connects the event handlers. As a result, pressing a button will trigger the click handler from your JSX. When React wants to re-render a component, React calls your function again. Your function returns a new JSX snapshot. React then updates the screen to match the snapshot your function returned. Calculating the snapshot, updating the DOM, document object model tree. That's your form, send, yeah. Okay. As a component's memory, state is not like a regular variable that disappears after your function returns. State actually lives in React itself as if on a shelf. Outside of your function, where React calls it your component, it gives you a snapshot of the state for that particular render. Your component returns a snapshot of the UI with a fresh set of props and event handlers in its JSX, all calculated using the state values from that render. Alright. Illustrated by Rachel Lee Neighbors. The ambulance. Oh, that was a fire truck actually. That was a fire truck passing by. Alright. Lovely. Random. Okay. You tell React to update the state. React updates the state value. React passes a snapshot of the state value into the component. Here's a little experiment to show you how this works. In this example, you might expect that clicking the +3 would increment the counter 3 times because it's calls set number 3 times. See what happens when you click the +3 button. Well, it's only going to increment by 1. Yes. Okay, notice that the number only increments once per click. Setting state only changes it for the next render. During the first render, number was 0. This is why in that render on click handler, the value of number is still 0, even after set number +1 was called. Here is what the button click handler tells React to do. Do it, do it, do it, and it's still just starting from 0. Even though you called set number 3 times in the render event handler, is always 0. So you set the state 3 times. This is why after your event handler finishes, React re-renders the component with number equal to 1 rather than 3. You can also visualize this by mentally substituting state variables with their values in your code. Yeah, exactly. For the next render, so that the render click handles look like this. Fair enough. And state over time, yeah, blah, blah, blah. So, well, that was fun. Try to guess what clicking this button will alert. Okay, set number, alert number. It'll be 5, right? 0. Okay. Sure. So it's 0. It alerts number 0. Yeah, okay. That kind of makes sense. Obviously. Yeah. Because we were just talking about state as a snapshot. If you use the substitution method before, you can guess the alert shows 0. But what if you put a timer on the alert so that it fires after the component re-render? It still says 0. It says 0. There we go. Okay, so surprised if you use the substitution method, you see the snapshot of the state passed to the alert. The state stored in React may have changed by the time the alert ran, but it was still scheduled using a snapshot of that state at the time the user interacted with it. The state variable value never changes within a render, even if its event handler code is asynchronous. Inside that render's onClick, the value of number continues to be 0 even after the set number 5 was called. Its number was fixed when React took the snapshot of the UI by calling your component. Here's an example of how that makes your event handlers less prone to timing mistakes. Below is a form that sends a message with 5-second delay. Imagine this scenario. Okay, you press send button, sending hello to Alice. Before the 5-second delay ends, you change the value to the to field to Bob. Okay. What do you expect the alert to display? Would it display you said hello to Alice? Or would it display you said hello to Bob? Alice, right? I think Alice. I can't even say, okay. Let's see. Alice, Bob. Send Bob. Yeah, it's still Alice. You don't need to worry about whether the state has changed while the code is running. But what if you want to read the latest state before a re-render? You want to use a state updater function. Covered in the next page. Setting state requires a new render. Try out some challenges. Here's the crosswalk light component that toggles when the button is pressed. Does it make a difference whether you put the alert before or after the set walk? Show solution. Whether you put it before or after the set walk call makes no difference. Yep. Alright. Not bad. Alright. Choosing the state structure. Alright. Before I continue, just gotta answer a message real quick. Okay. Oh, okay. Choosing the state structure. Structuring state well can make a difference between a component that is pleasant and hard to debug, and one that is constant source of bugs. Here are some tips you should consider when structuring state. When you use a single versus multiple state variables, what to avoid when organizing state, how to fix common issues with state structure. Okay. Just reducing the table height. I'm gonna do a monkey type real quick. Just need to type real quick for the funs, for the lulz. Oh my god, what just happened? Banana. Yeah, my hand's frozen enough to have difficulty typing. Accuracy penalty. -47. Sad. Okay. Ooh. Choosing the state structure. Principles of structuring state. Reduce duplication when you can. In a flat way. Avoid contradictions in state, group-related state. The goal behind these principles is to make state easy to update without introducing mistakes. Yeah, I see. Make your state as simple as it can be, but not simpler. Now let's see how these principles apply in action. group related state. Technically, you can use either of these approaches. Then you won't forget to always keep them in sync. Okay. Another case where you'll group data into an object or an array is when you don't know how many pieces of state you'll need. For example, it's helpful when you have a form where the user can add custom fields. Mostly plug and play. Another case where you'll group data into an object or an array is when you know how many pieces of state you'll need. For example, it's helpful when you have a form where the user can add custom fields. Yeah, fair enough. If your state variable is an object, remember that you can't update only one field in it without explicitly copying the other fields. For example, you can't do set position in the above example because you would not have the y property at all. Instead, if you want to set x alone, you would either do position x or split them into two state variables and do set x 100. Alright, remember. Avoid contradictions in state. Whoops, I'm going up when I'm meant to go down. Avoid contradictions in state. Here is a hotel feedback form with sending and is sent state variables. How was your stay at the Prancing Pony? While this code works, it leaves the door open for impossible states. The more complex your component is, the harder it is to understand what is happening. Let's see more code here. Set is sending, await send message, set is sending, set is sent. Yeah, there's a lot to carry on. While this code works, it leaves door for impossible states. For example, the harder it is to understand, since is sending and is sent should never be true at the same time, it is better to replace them with one status state that makes one of the three valid states: typing, sending, and sent. How was your day at the Prancing Pony? State typing, sending, Sent. Await send message. No, okay. Set timer for 2 seconds. You can still declare some constants. I gotta sometimes like consider some snippets, good snippets, you know, like set timeout snippet, new promise, resolve, set timeout resolve 2000. That's like a good thing to have. Okay. You can still declare some constants for readability, but not state variables. You don't need to worry about them being out of sync with each other. Avoid redundant state. If you calculate some information about a component's props or its existing state variables during rendering, you should not put that information into the component state. You should not put that information into the component state. For examples, take this form, it works, but you can find any redundant state in it. Well, full name, yeah. Full name. Yeah. Here, full name is not a state variable, instead it calculates during render. Don't mirror props in state. As a result, the change handlers don't need to do anything special about it. When you call set first or set last, you trigger re-render. Calculate for this. Don't mirror props in state. A common example of a redundant state is code like this. Mirror props. The problem is that if the parent component passes a different value of message color later, the state is only initialized during the first render. Oh, you're right. That's crazy. This is why mirroring some prop in a state variable can lead to confusion. Instead, use the message color prop directly in your code. If you want to give it a short name, use a constant. That's big. That's big. Okay. So don't mirror props in state. That's actually something I want to save. Okay, I wrote that down, kept that as a side note. So here is a color state. variable is initialized. Shorter name to a constant. This way it won't get out of sync with the prop passed from the parent component. Mirroring props into state only makes sense when you want to ignore all updates for a specific prop. By convention, start the prop name with initial or default. To clarify this new value, to clarify that new values are ignored. Yeah, okay. Avoid duplication in state. This menu, yo, this is huge, this is long. There's so much to read. I know I should just stop when I want to, but, you know, it feels good to actually finish some of this sometimes. Sharing state between components. Sharing state between components. Okay. Avoid duplication in state. This menu list component lets you choose a single travel snack out of several. Pretzel. Granola bar, pretzel. What is your travel snack? Avoid duplicate in state. This menu component lets you choose a single travel snack out of several. Currently it stores the select Neovim object. Consisting of the same object as one of the items inside. Duplicated in two places. Why is that a problem? Let's make each item editable. Picked pretzels. Although you could update the second item too, an easy fix is to remove duplication. Then instead of selected item object, select ID, and then go to the selected item by searching items array as an item of that ID. Okay. The state used to be duplicated like this. But after the change, it's like this. The duplicate is gone and you can only keep the essential state. If you edit the selected item, the methods below will update immediately. Avoid deeply nested state. Yeah, it is very deeply nested, isn't it? Now let's say you want to add a button to delete a place you've already visited. How would you go about it? Updating nested state involves making copies of objects all the way up from the part that changed. Such code can be very verbose. If the state is too nested to update easily, consider making it flat. Here's one way you can restructure this data. Instead of tree-like, you could have each place hold an array of its child's place. Store a mapping for each place ID to the corresponding place. Right. This data restructuring might remind you of seeing a database table. Now that the data is flat, also known as normalized, updating nested items becomes easier. Here's how you could do it. You can nest it as much as you like, but making it flat can solve numerous problems. It helps ensure you don't have duplication in different parts of a nested object. Improving memory usage. Ideally, you would also remove the deleted items and the children from the table object to improve memory usage. This version does that. It also uses imma to make the update logic more concise. Sometimes you can also reduce the state nesting by moving some of the nested state in the child components. Alright, I'm going to say we're good here. Sharing states between components. But now let's say you want to change it so that only one panel is expanded at any given time. With that design, expanding the second panel should collapse the first one. How would you do that? To coordinate these two panels, you need to lift their state up to a parent component in 3 steps. Remove state from the child components, pass hard-coded data from the common parent, and add state to the common parent to pass it down together with the event handlers. Step 1, remove state from the child component. Yep, now the panel can control is active by passing it down as a prop. Pass hard-coded data from the common parent. As children. Add state to the common parent. Almaty. It's common to call a component with some local state uncontrolled. For example, the original panel component with an isActive state variable is uncontrolled because its parent cannot influence whether the parent panel is active or not. Uncontrolled components are easier to use with their parents because they require less configuration. but they're less flexible when you want to coordinate them together. Controlled components are maximally flexible, but they require the parent component to fully configure them with props. In practice, controlled and uncontrolled aren't strict technical terms. Each component usually has some mix of both local state and props. However, this is a useful way to talk about how components are designed and what capabilities they offer. When writing a component, consider which information in it should be controlled via props and which information should be uncontrolled via state. But you can always change your mind and refactor later. Controlled and uncontrolled via props and state. Sharing state between components React. Alright, and I'm looking for controlled and uncontrolled components. Okay, and then pasting that. A single source of truth for each state. In a React application, many components will have their own state. Some state may live close to the leaf components at the bottom of the tree, like inputs. Other state may live closer to the top of the app. For example, each client-side routing libraries are usually implemented by storing the current route in a React state and passing it down by props. For each unique piece of state, you'll choose the component that owns it. This principle is also known as having a single source of truth. Doesn't mean that all state lives in one place, but that each piece of state there is a specific component that holds that piece of information, instead of duplicating shared state between components, lifting it up to their common shared parent and passing it down to the children that need it. Your app will change as you work on it. It is common that you will move state down or back up while you're still figuring out where each piece of state lives. This is all part of the process. To see what this feels like in practice, with more components, read Thinking in React. Yup, okay. Pass event handlers. Pass event handlers so that children can change the parent state. I'm thinking like on click, right? On show. Set active index. Okay. Yeah. Okay. That's it. No, we got more. Okay, update the person component we've been using above. Add 2 separate input fields from the first name and the last name. Other users should be able to update the first name and the H1 element with every keystroke. There are many ways you can do this. Keep in mind that you've learnt in this session while coding it out. Yeah, nah, I'm probably can't be bothered. Okay, so that's a lot of information. Let's build. Let's see what we have. Oh no. Docs. We got issues on the docs. Nav pass stories. Desktop. Mm-hmm. Three of the same things. Yeah. Resizable. If only. Draggable, resizable, rotatable. Embed stories, add padding to storybook canvas. Docs, inline, iframe height. Storybook v7. Inline stories. Okay. Where does this even go? Story parameters. Viewports. Parameters. Docs. Story. Inline. False. Iframe height. 700. I don't know if this works. That kind of worked. Half worked. Control. Wait, what is this? Unable to index stories navbar MDX. Invariant failed. Could not load a .navbar .stories. desktop, mobile. Okay. iframe. What? Why doesn't it work now? Like, npm run storybook. Navbar. What? Small mobile. Default viewport. 100. One hundred. 100. Now something's up. No. It's not even doing what I want anyway. Man. I'm not considering this properly. It's not the right way. Default viewport, mobile. Yeah, default viewport. Why doesn't that work? Oh, because it's mobile, not mobile 1. Ah, default viewport for this as well. Examples on the other hand, there is none. As of yet. Okay, let's just try playing around with it. Netbar.tsx. All the classes, filter, boolean, join. Sure. Navigation. Calendar, ref. As opposed to going to an actual calendar. Okay, just gotta consider that later. I'm fine with open menu item. Your profile, settings, sign out. Disclosure panel. Disclosure button. Should I keep this all together? Like, how much of it is actually going to be reusable? Okay. Classes. This is the one thing that's tripping me, I think. Why? Like, what does it do here? Class names. Item.current. If it's true, then text white, BG dark, text gray, hover, let's see. Tab. Let's just see. I just want to see. Yeah, team projects reports. Text gray, hover, text white, rounded, markdown, classes.filter. Calendar, tasks, you know, maybe there's a specific tasks view. We'll just keep it as that for now. Calendar and tasks. In the mobile view, calendar, tasks. Man, I closed it. Yep. Yep. Let me see the current npm. So nvm use cd front end nvm use npm run dev. Command click. Dashboard, items, user settings. Was that really all it was? Surely there was more to it. I was just... Docker compose up d. Items, user settings, admin. Okay, all right. Huh. Okay, surely I can use some logic from that sidebar. Sidebar. Mobile desktop. Sidebar items. Oh, okay. Sidebar items takes an input on close. Use query client. Hmm. Sidebar. Sidebar items. Well, how... How? Alright. We'll put on some lo-fi music while I try and figure this out, I think. We'll do that.
Maybe you've noticed that a lot of people are using this cn utility function when you work with Tailwind. In this video, I'll explain why people are using this. So let me remove this for now. Let's start from scratch. Now we have a clean slate. And what's the problem with this? Why do we need anything else? Well, in the real world, when you're going to use this button, for example, here on a page, you also want to have the ability to pass class name here, right? So here we want to pass a class name prop. So just like styling it on a native element, we want to be able to style it on our own custom component as well. And here I may actually decide to override the default background color. So here I actually want to pass BG green 500, let's say, right? So the button has a BG blue of 500 as default background color. And now when we use this button in this instance here, we actually want to pass BG green 500. So here this button now needs to accept a class name prop. So we can say class name, and let's quickly type this for TypeScript. So we'll say type button props, and we can actually use a type from React. So it will just be button HTML attributes, and then we pass in HTML button element. So basically what this will allow us to do is pass any props here that you can also accept here on the native button element. Class name is one of them. So now this class name has that BG green 500. How do we add that here? So typically you would try something like this, convert this to a template literal, and now you can try adding the class name, right? So you would do something like this. So now this is going to be BG green 500, and this will be BG blue 500. So now there is a conflict. And the problem with Tailwind is these conflicts are not predictable. You don't know the outcome really. It doesn't matter if you put this at the front of the class list or at the end. In both cases, when you have a conflict, you don't really get the result that you expect. In general, people expect that if you put it at the end of the class list, that this one wins if there is a conflict. And that's not the case by default. By default here, we don't really know what's going to happen. The solution for this is something called Tailwind Merge. And I have a complete separate video on this one. It also solves some other problems. You can see it's been exploding in the past few months. So I'm going to install that. npm install Tailwind Merge. All right, so I have installed this. And what we get from this package is a function called twmerge. So I will import that. So now we're going to wrap this entire string in this function. So I'm going to call that function. I will just say twmerge, and I have parentheses here. Let's see. So what we're going to do is we're going to pass the first argument here. Those are going to be the base classes. All right, so now what we have is we're calling this function twmerge, and we're just passing our base classes here. That's the first argument. The second argument can then be the class name. So here we can actually that class name, right? So we're just calling a function twmerge. It has two arguments right now, this base string of base classes. And then we have class name here as the second argument. And the benefit of doing this is now when there is a clash, and we still have a clash because we're passing in BG green 500, which clashes with BG blue 500, we can now be rest assured that BG green 500 will win, which is what you want, right? So you expect to override the base classes when you put in a class name like this as a prop. So now when it comes later, it will actually win, which is in line with our intuition. And there can be other conflicts as well. For example, here we have padding y2 and padding x4. But what will happen if I now pass in p-5? And so here I'm saying on all sides, the padding should be 5. And here I have some other classes. So they conflict in a way, but the class names are slightly different. And Tailwind Merge will also make sure that that conflict is also resolved intelligently. The second problem you're going to run into in the real world is when you have conditional classes. So we may have some kind of pending state. So let's say pending, set pending, and I will quickly import this. So now depending on the pending state, we may want to change the background color. And we can very easily do that with Tailwind Merge as well. I'm actually going to remove text white here as well, so we get some extra space. So now we have our base classes in this first string here. Now we get the class name as a prop here. And now what you can do is you can simply have another argument here. And you can simply say if pending is true, it should become BG gray 500. So now we have our base classes here. We then pass a class name. And then we also have some conditional class here. So depending on whether this is true or false, will this BG gray 500 be applied. Right, so Tailwind Merge is a really handy library. Now there's one downside, or at least some people think it's a downside, which is that you cannot use an object here for these conditional classes. So what some people want to do, if I comment this out, what some people want to do is instead of passing this pending and an ampersand, some people want to do an object here. And then you have basically as a key the string that you want to apply with the Tailwind classes, depending on the value of some variable. But as you can see here, this is not possible here with Tailwind Merge. However, it is possible with a library called CLSX. So with CLSX, you also solve that problem of conditional classes, and you can actually pass this with objects. So you can write it like that. Now CLSX does not solve the other problems. So when you have conflicting styles, CLSX doesn't help with that. So what the author of Tailwind Merge has suggested is that if you really want to use that object style, you can use CLSX and Tailwind Merge together. So you can first pass everything to CLSX, and then the result of that you pass to TW Merge. And this is basically the CN utility function. So I'll show you how to implement that. Now it's been popularized recently by this UI library ShatCN. So now we're going to combine CLSX and Tailwind Merge, so we also get that object possibility. I'm going to install CLSX, npm install CLSX. So what we want to be able to do is, instead of using pending ampersand, because some people don't like this syntax, some people really want to use this object syntax, which is not possible in Tailwind Merge alone. So now we're going to replace this with the CN utility function, which we're going to create now. Right, so this is the result that we want. We want to be able to write this. All right, so I've saved here, and let's put that function in a utilities file, and that's going to be the following function. So we're going to export that, and we're going to call that CN. So let's see. So CN needs to use that TW merge function, but before we do that, we want to pass everything to CLSX, so we can use that object syntax, and then the result of that will be the argument for TW merge. So let me import this, TW merge, and let me also import CLSX from CLSX. All right, so now the input of this function here, when we call this CN, first it's a string, then class name here, which could be a string, but now also an object actually. So now we also should be able to pass an object here, and then of course we have the object here for a conditional class or multiple conditional classes. So we have these inputs here, but we're using TypeScript here. So what type is this going to be? Because we have different types here. Well, CLSX actually also gives us the type that we can use here. And these are all class values, and it should actually be singular, so class value. So what we're actually going to do here, all these inputs, we're going to wrap them up in an array. So we can use this REST syntax here, which will put everything in an array. And then we can just say the input here is basically an array of class values, right? And then we pass the inputs to this CLSX function. And so first the inputs will go through CLSX, which makes the object syntax possible. And then the result of that will be passed to TW merge, which will merge conflicting classes intelligently. And then of course also add the return keyword here, right? So make sure you return whatever the result of this is. And now I can import this. And now we have the final format of this function, and also an example of how you would use that in this syntax. So typically what you also want to do here is you get other props here. So a button component may also want to have, for example, type is submit, right? So other attributes that you would typically have on the button element. We also want to pass that through here as well. So we typically also want to put everything here. Maybe instead of REST, we can call it props, and then we can just spread that here as well. So just spread that out here again. Now, to really make this button reusable, we also want to pass the ref here, for example. So we want to be able to pass a ref and also children, for example. But I'll have a separate video on how to build a complete reusable button component. Now, it looks a bit complicated, and if you really want to become a professional React Next.js developer, check out my React Next.js course. Also, make sure you've mastered the fundamentals. Those are both JavaScript as well as CSS. I have courses on them both. Check out the link